our sponsors. We have with us today Mr. Padma Prasad, Head Business Development, and also Mr. Yashwant from Cyberverse Foundation. I welcome Mr. Padma Prasad, sir, to deliver a few words on this occasion.
Respected Dr. Pratosh, very nice to hear from you that you remember those fond memories of Mysore, dignitaries on the dais teaching fraternity, and my dear student friends. I remember my old Macmillan publishing days to
towards Haiti.
So before we start the event, I request everyone to kindly switch off your mobile phones. A very good morning to one and all present here. I, Padmini MS, Assistant Professor, Department of Computer Science and Engineering, take the privilege to welcome one and all present here. We have assembled here for the keynote session addressed by Dr. Pratosh AP, Assistant Professor in the Department of Electrical and Communication Engineering, IISc Bangalore. A warm welcome to you, sir. And also I would like to welcome Dr. Ashok Rao, sir, Director, NIEMC, to this event. A warm welcome to you, sir. Now it's the time to have the keynote session by Dr. Pratosh AP. Over to you, sir.
It's okay. Yeah, thanks. Sure. No, I don't want it. Yeah. Okay, so good morning, all. Do we have any students in the hall? Okay, great. So why don't you come over here? No, it's okay, fine, yeah, so no problem. Had there been a whiteboard here, it would have been much better, actually, yeah? So all of you are undergrad students, right? BTech, B. So which year are you people in? Okay. So can I assume that you people are good with your class 12 calculus? See, I keep saying that I don't assume anything beyond class 12 calculus, right? So rest can be developed. Okay, yeah, can wait. Perhaps let's get started by the time they bring the board. Okay, first of all, it's It's an honor to be talking in front of my teacher, like, who rightly or wrongly motivated me to take up this profession, right? So at times I don't know if I did a right thing by taking up this profession, but yeah, so thanks to him, or like no thanks to him, that I'm here. Yeah, that's okay. Yeah. See, the very problem is that if you are in this profession, you don't get anything beyond a bouquet, right? So when I was your age, and I'm talking to students, I thought these are good to have things, but I've realized that there are more important things in life, so money being one of them, right? So it took me 3 decades to understand that money is something that is important. I'm not talking about money, it's about economy, right? It's not about the currency note, right? So anyway, so let's get started. As I said, right, I mean, I owe a lot of things that I've been doing to teachers like Professor Rao, right? So there are lots of teachers, and a few of them will create such an impression on you, so, that, see, I think, it has been 15 years since he actually taught me in a classroom, but we are still here together, and whenever I come to Mysore, I meet him, and it's been more of a friend than a teacher now, talking of all kinds of things. That's one good thing about this profession, that you get to create such long-lasting impact on people's life. You get to shape them, and they always come back to you. And I've been in this profession for about a decade now. I've taught at IIT Delhi, now at IISc. I have students everywhere, so I go to give, I kind of give keynote talks in different places. Just 15 days back, I was in one of the corporate events I go to, and there are students all over, right? So it's really a pleasure to be in that position. Anyway, so I'm supposed to talk about AI today, okay? And just waiting for them to complete. Done? Yeah. Okay, so we are supposed to talk about AI. So what I thought was, see, I could have taken one of the recent algorithms that came from our lab and given a talk on that, but I don't intend to do that in front of this sort of an audience. So I'll tell you my objective. My objective here is to kindle a sort of interest in all of you, to take this up as an area of interest. Beyond, I'm sure that I was told that you have a long weekend and a lot of your friends are at home because you have a longer weekend. The fact that some of you people are here shows that you are at least remotely interested in doing something more than getting a degree and getting a job out of campus. I'm not being judgmental. It's not bad to get a job. As I said, it took me 3 decades to understand that job is important, but beyond that we'll do something. Yeah, let them fix it up. So do you mind bringing it here? That's why I asked you people to actually come here so that you can have a better visual here. Can you hear me without the mic? can't have this and also talk. Enough, yeah. Saku, enough. Oh, this is enough. Okay, I'll manage. It's fine, thanks. Yeah. It's okay, you can ask them to leave. Yeah. Okay. So is there anybody here who has not used ChatGPT to solve your assignments or no? You don't use? Really? Yeah. My students do it all the time. So you give them an assignment, they'll ask ChatGPT to answer it and see, one of the biggest challenges being in academia going forward is how do you create questions and assignments that are ChatGPT proof? Yeah, exactly, right? We have to do it actually, right? I mean that. Okay, so all of you have used ChatGPT, right? Right. It's smart, isn't it? It's smarter than most of human beings that we encounter on a daily basis. In fact, one of my students from IIT Delhi who is in touch with me, the guy has purchased a subscription of ChatGPT, has paid for it and subscribed. He said, after subscribing to ChatGPT, I've stopped talking to a lot of people. No, he said this, right? It's because it's smarter, right? And it has no emotions. So you can see, think about it. Suppose you want to learn something and you are interacting with a teacher. No offense to any teachers here. Me being one of your own, right? But suppose you are a student interacting with a teacher. Now you don't understand something. Okay, you ask a question. So if your teacher is humble enough, they'll say okay, and they don't know the answer. They'll say okay, I don't know. Let me get back. It seldom happens, right? So more often than not, what will happen is, either they'll try to brush you away. They'll say, okay, I mean, this. See, I keep saying that schooling system that we have in India is actually a preparation to make people stop asking questions. They give 12 years of preparation to ensure that people don't ask questions, and it was designed that way by choice, right? So British wanted people who are skillful but should not ask questions, right? So the school was designed that way, that they should be skillful to do whatever you are asked to do, but they should not ask questions. So deliberately, the curriculum was designed in such a way that people stop asking questions, but they are skillful, right? So now if somebody survives that system and still asks question, we are very uncomfortable taking questions because we have been a part of the same system that discourages asking questions, right? So they brush you aside. So now ask the same question 4 times, the teacher will get angry, right? So they'll hold some sort of a grudge against you and say, okay, I'll see you when your assessment comes in, right? Now imagine interacting with a ChatGPT which will never get angry. You can ask the same question 100 times and it will give you answers in 100 different ways to ensure that you are understanding. Isn't it a better companion than having a teacher? Right? So now some of you might have girlfriends, boyfriends and spouses, right? So talk to them 5 levels of conversation, right? They get angry. Either they get angry or they get start crying and become very emotional, whatnot, right? We have all experienced this. So imagine having an emotional companion who will never cry. You can keep talking with ChatGPT, flirt with it, right? Ask it questions. Isn't it? Come again? It'll never ask for chocolates, of course. Right? You don't even have to be materialistic. So, as funny as it might sound, this is going to happen. That's exactly what my student Arvind told me, that after taking subscription from ChatGPT, right, I've stopped talking to people, because most of our needs as human beings, be it intellectual, be it emotional, is now being catered by the AI agents. It's a reality. Okay? Now this means that human beings now has an existential crisis. Isn't it? So now I always compare this with the industrial revolution that happened in Europe. So before machines came, that could lift heavy objects. Lifting heavy objects was a skill that was valued. Right? If somebody could lift a very heavy object, that was considered to be a skill of worthy of possession, because there was a lot of work that was supposed to be done by lifting heavy objects. Right? Come industrial revolution, all these mechanical machines, all these people became redundant and useless. And that's why if you have read some history, lot of protest happened when machines took over factories, because everybody had existential crisis. Exact same thing is going to happen in a decade now. Right? Intelligence, as we know, is overrated. It's time that we realize that intelligence is overrated. Right? So there was a time when people who could do additions quickly were valued. So these were the the clerks and carcoons in British Empire. Now come calculators. So if you say that I can add two 4-digit numbers or whatever, right, quickly in 2 seconds, nobody cares. Right? Exact same thing is going to happen to lot of skills that we possess today as human beings. It is going to happen. It's just a matter of time that it is going to happen. I don't know if you people know this or not. AI can code well now. Right? Most of the things that are taught in a programming 101 course in computer science curriculum today in colleges are done much better using AI. So now what are we doing? So it's actually time to introspect and ask this question. See, the good news is that human beings are always ahead of machines, in the sense that we find new problems to solve. Right? So, but now we are in this era where we will face very, very strong existential crisis, and a lot of the mundane so-called intelligent tasks that we were doing today will be taken over by AI, and this is going to happen for sure. Okay? Now the question is, how is this AI so capable suddenly? Right? What made it capable is the question. So that is the question that I want to address and give you some perspective of why I think this capability suddenly emerged. Okay? It was not there a decade back. Was it there? It was not there. Right? So it suddenly came. So what made it possible? Okay? So my perspective is the following. The theory was there, the ideas were there. What was not there was smart engineering. Okay? So one or two smart ideas, one or two tweaks, engineering tweaks that were done, has what enabled this sort of an intelligence to come up. So what I want to do is that just tell you the story of AI. So how this so-called AI started historically, right? And how it transformed to what it is today. Is it of interest to you? Or perhaps you can ask ChatGPT to prepare a keynote address to your conference, and it will do, actually. Right? So I keep saying that now that intelligence is overrated, okay, or our intelligence is rather taken over by machines, what do you think makes us humans humans? Did you get my question? So now intelligence is taken over. So we were boasting our intelligence. We said that, okay, we are different from machines or animals or whatever, right? Because we are intelligent. Now that intelligence is gone, what do you think makes humans humans? Come again?
Morals and ethics.
Well, yeah, that's one thing. He's saying morals and ethics. How do you define that?
So AI can do right things and as well as wrong things. So humans will know what is the right thing and what is the wrong thing.
Fine. Don't you think it's subjective? See, what is right for you now and here may be wrong for somebody else, somewhere else, in some other time. Let me ask you a question. Is killing right or wrong? What do you think?
Wrong in most occasions.
Yeah, so there are exceptions. So now if you say that killing is wrong, see, all these are very important questions, right? Now that you brought in. And if you say that killing is wrong, so what should an army guy do when he's confronted with an enemy in a war? So there killing is his duty. Now who defined what a country is and who defined what the borders are? If you think about it, so there is a point in time where some random guy draw a line, right? Drew a line and said that, okay, you people are different, right? So now after that point in time, people who think that they are different started quarreling. This, right? So anyway, so that's one good point that you made, that ethics is one area which makes humans humans. The other interesting thing that I'll tell you is, do you know what is the ultimate test of an AI agent? Have you heard of something called Turing test? So there was this one guy, Alan Turing, who started some of these ideas. He came up with this test called Turing test, which he called the ultimate test of intelligence. I'll tell you what that is. So now suppose you have an AI agent, okay, and I will blindfold you. That means I'll blindfold you, and I'll ask you to interact with an AI agent and a real human being, right? So now an AI agent is capable, is said to be passing the Turing test if the human that is interacting with the agent cannot distinguish between the human and the agent, right? So do you think now Turing test, the ChatGPT has passed the Turing test? It has, actually. If you blindfold and ask people to interact with ChatGPT and a real human being, turns out that you will often mistake ChatGPT to be a very wise human being, because human beings are often stupid. So it has passed the Turing test. But one other wise man once told, so we all talk about AI taking over everything and all that, right? Scared of AI. This person said that I'm not scared of AI that passes Turing test. I'm scared of AI that fails Turing test deliberately. Did you get what I said? Right? So have you watched the movie Her? If you have not, right, you should. Okay. It's a very interesting movie, H-E-R, Her. Okay. Where there is this is a spoiler alert, right? The AI will actually fail the Turing test deliberately. So now that's very deep and impactful, that what makes humans humans is their ability to intentionally cheat. It's the intent, right? Human beings can cheat, AI can't. Right? So if you look at it, it's not the intelligence that made progress possible in human history. It was never intelligence. Intelligence was always used as a tool. So what made progress in human history are some of these so-called human traits like greed, right? And the intent of human beings to conquer, the greed to power, and the intent of human beings to rule over the world. I'm talking about Second World War. So a lot of technology was developed, and people who are intelligent were just used as tools, right? So what makes human beings are their ability to boss over people, or is their ability to cheat, right? And these kinds of traits. Anyway, so we are not yet there, and my personal belief is that AI can never reach there. Okay, so it can be very, very intelligent. It will be much more intelligent than all of us put together. It's going to happen. But it will always be subservient to human beings, because it will never have intent. Now that's my philosophical take about AI, right? Anyway, having said that, now let's get to a bit of math and theory and technical stuff. So now what made AI a possibility? Okay, which was not there. So what do you understand by this word AI, mathematically or even from an engineering perspective? So in your class 8, or rather 9, I don't know, when did you study that? So did you do curve fitting? Given some points, you just wanted to fit a curve. Did you do that in your class? Did you remember doing it? So what was the problem? What was the problem? You were given a set of points and you wanted to basically connect the dots. right? It need not be straight line always, right? Why should it be a straight line? So now suppose I give you whatever, right? I give you a few points like this and ask you to connect the dots. How can you connect the dots? Why should it be straight? What if I have a curve? The reality is like this. If I have reality like this, right? And if I only show you this and ask you to connect the dots, you might as well mistake the reality to a line. So why do you start with the line in the first place? If I give you a point, a few set of points and ask you to connect the dots, you start with the line. Why? Not necessarily. Easiest actually, right? So how do you quantify? It's okay. I think they can hear. Oh, I see. This is unfortunate. I want to use the board. No, it's okay. I'll manage. So let's not distract. You can hear me, right? Oh, I see. If it were to be ChatGPT giving this keynote address, right, it would not be unhappy that there was a distraction. I don't know if you get the joke. See, people have become so serious and lifeless these days that when I crack jokes in class, I'll have to tell them that this is a joke. Anyway, let's get back. So I said the easiest choice is a line because there is this one nice theory called Occam's razor that would say that if you have competing hypotheses, then the one that is the easiest, right, or the simplest is the one that is supposed to be generalizing. Anyway, so you start with a line, fine. So now you'll be surprised if I tell you that ChatGPT is essentially doing this. All it is doing is fitting a line, or rather a curve to a given set of data points. That's all it is doing. So you'll be surprised how. Now think about it. Now, if I give you these points and ask you to connect the dots, you start with a line, okay? And suppose you do this. You say that, okay, here is my best fit in whatever sense. Now, as I said, what if my reality is like this? If my reality is like this, and if I only show you the points in the left-hand side, then you have a wrong model, isn't it? Why? Because you have not seen the actual reality. You are too far from the reality. Now, why do you need a model? Why do you want to connect the dots? Exactly, right? I mean, you connect the dots because you want to predict. Right? So, if you look at all the problems in science and engineering, what is important is predicting what is going to happen given a particular set of initial conditions, isn't it? Starting from laws of motion, Newton's law of motion, you want an equation, or you want, okay, so see this equation that you know of, right? This is a line, isn't it? Isn't this a line? This is a line, right? So now why do you need these kinds of relationships is because if I can measure, let's say, acceleration, I want to know what the force is. So basically I want to predict what the next point is going to be, and that's why I need models. Right? What is a model? The curve that you actually fit, right? The equation of the curve that you fit is what is called as a model. You understand? So why do we need models? We need models because we want to predict what is going to happen next. Now this problem was of importance to human beings historically. From the times of Kepler. So Kepler wanted a model to predict the position of planets. So he was observing, some sort of structure in the position of planets, and he wanted to basically connect the dots and predict where this particular planet is going to be in the next point of time, right, given this data. So that's basically curve fitting, and this problem has been around, isn't it? Newton had the same problem. So he did some measurements and he wanted to connect two quantities, which are the force and acceleration. And this is a model. Got what I'm saying? Now, what is intelligence? Think about it. Intelligence is a model that we have, right? So there are two things that you need when you are building a model. You want observations, and you want things that are to be predicted. So here, accelerations can be your observation that you measure, and what you predict is force. You understand what I'm saying? Right? So similarly, any model, you make some observations, and you do some prediction. You want a framework where you can connect your observations to future. That's your model. Right? What sort of models do you need for intelligence? What do you see, and what do you observe, and what do you want to predict? Give me examples. You got my question, right? Or maybe I'll expand. So in all engineering, right? So you see something, you make some observations which are measurements, and you want to predict some other variable, right? So you have actually one or more variables. You observe one of them, and you want to predict the other that you think is related to the one that you have observed. So what connects what you have observed to what you want to predict is a model, isn't it? But here the example is you measure acceleration, so you want to predict force, and you want a relationship that connects acceleration to force. So similarly, in intelligence, what do you measure and what do you want to predict? Okay, let's take an example, a concrete example. So all of you have used the mic icon that is there in YouTube, right? Isn't that AI? You understand what I'm saying? So there is a small mic button in YouTube, right? You press that, and you can actually dictate AI whatever you want to search for, and AI predicts whatever you have said, right? So that's a prediction, isn't it? You understand? Just like force and acceleration, so there's some measurement that's happening, and there is some prediction that's happening, isn't it? What is being measured and what is being predicted? Okay, yeah. So yeah, I mean, when you type, you can predict the next word, right? And YouTube, the example that I give, you think about it. It's very deep. I don't know if you people have even thought about it. See, what is getting measured there is actually the change in atmospheric pressure. No? Electrical engineering 101. When you speak, what is happening here? There's actually a physical capacitor that is there. It's not a wave. There's actually a capacitor that is sitting there, which is a condenser microphone. And as you speak, there's a change in atmospheric pressure. Right? That is being measured, being converted into an voltage, which is passage of electrons using this sensor. So what is being measured physically is change in atmospheric pressure as a function of time, which you call a speech signal, isn't it? Now what is being predicted? Phoneme or words. Can you measure words? Can you measure words? So it's an abstract concept. See, when I say some letter, let's say A, the idea of A that you get is an abstract entity. You can't measure it. You understand what I'm saying? So now what you want to connect is something that is physical and measurable to something that is as abstract as a phoneme, which is only in the minds of human beings. So here force is measurable, acceleration is measurable. But when you are modeling intelligence, only one of them is measurable, the other thing is never measurable. Think about it. Let me give you another example. Let's say that you are building a face recognition model. That's one other application of AI. Right? So looking at a picture, you want to find the identity of a human being. Correct? Right? What gets measured there? So what gets measured is the reflectance of this object. When light falls on your skin, right, or on an object, there's some bit of light gets reflected, and there is a sensor that is there which is measuring the amount of reflected light that is coming from an object. Measurable, that's your image. So you represent that as a matrix and pixels, etc. That comes later. But what's getting measured is the reflectance. And what's getting predicted is this idea of identity, which is a complete human construct. So let's make the problem easier. So let's say that you want to predict whether the picture is of a male or a female's picture. The idea of male and female is extremely abstract. You can't measure it. Can you measure the maleness or a humanness, your femaleness? You can't. Can you measure identity? You can't. Right? So now the model that you are seeking right now in AI is between something that is completely measurable and something that is extremely synthetic and human constructed. Do you get what I'm saying? You take any AI for that matter, right? This is exactly what is happening. So now let me give you another example. So one other application of AI is where you want to classify emails as spam or non-spam, right? The idea of spam is not measurable, isn't it? It's completely human constructed. What can be spam for me may not be spam for you and vice versa. Now the question is, how do you build models between things that are measurable and things that are very, very synthetic and human constructs? Get the idea? Now what happens is, nature is simple, right? Whatever you get in nature and what things that you can measure are simple, and that is why you can fly an aircraft just by having 3 equations of motion. Do you know that you don't need anything other than Newtonian mechanics to fly an aircraft? You don't need AI to fly an aircraft. Do you know that? You people know that or not? To fly an aircraft, AI is not used. All you need is Newtonian mechanics, 3 laws of motion, that's all. Why? Because that is natural. You can fly a rocket, fly an aircraft, send a projectile out of the earth, etc., and all that, just by using a model that has 3 or 4 parameters. How many parameters that Newton's law of motions have? All of these are models now, right? How many parameters does this models have? How many parameters that this model has? 1. You are measuring F, you are measuring A. The intercept is 0. The only parameter is mass, which is a scalar. So this is a 1 parameter model, right? And if you have some displacement parameter as well, then you have 2 parameter model. So now you can explain or make predictions on everything that moves in this world using a 2 parameter model. Why? Because that is natural. But to simply identify whether a person is a man or a female, you need a billion parameter model, which is your convolutional neural network. Why? Because the idea of male and female is very synthetic. It's not natural. Right? To connect something that is measurable, which is an image, to some construct, a human construct like the manness or a femaleness, needs thousands of parameters, because the idea is not natural. And nature is simple. Human beings are extremely complicated. And these constructs are synthetic. They are not natural constructs. Fine? So now, how is this related to all that I'm saying? Now, people wanted to model intelligence, which means that they wanted to connect measurable things to things that are extremely abstract, or connect the atmospheric change of pressure into something that is called phoneme. Think about it. You measure the same change in atmospheric pressure irrespective of the language that I'm talking. However, if I build recognition systems for 2 languages, they have to work in completely different ways. But what is being measured for both of them is exactly the same. Which means that is why you need models that have billions of parameters. You understand? Yeah? So what happened is, people were doing predictions. But this question of predicting human constructs, when it arose, they found out that models that have tens of parameters, hundreds of parameters, do not work. Why? Because the underlying curve is not a line, it is not a parabola, it is not an nth degree polynomial, but it is some billion degree polynomial in some higher dimensional space which you don't know what. You understand? And that's why one big thing that happened is, this is one revolution that happened, that people started moving from models that are simple, that have limited number of parameters to, they still have limited practically, to models that have huge number of parameters. So now today, with the hardware that we have, and smart algorithms like backpropagation, which is repeated application of chain rule, right? You can handle models that have huge size. So now nothing changed from the time of Kepler to today. The only thing that has changed is we can handle bees. So do you know how many parameters that does ChatGPT have? Does anybody know? No? Sandesh knows that. Yeah. So the one, at least the open source one, Llama kind of models have 7 billion parameters. So now, a line is 2-parameter model, a parabola is a 3-parameter model, third degree polynomial is 4-parameter model. Imagine a billion degree polynomial, 70 billion degree polynomial. What is it? That is intelligence. So this only tells you that intelligence is overrated and human beings are extremely complicated. Just to explain, right, what is a man, what is a female, right? Just to identify a human being, you need billions of parameters, which means that the very construct of identity is complicated. And it is, I'll give you more evidence to what I'm saying. So of course, one was a huge size of model. You might ask, the size of models was there in 2015s, 2020s as well. So what changed in just 2-3 years back that made ChatGPT possible? Any answers? See, I said one is the ability to handle large scale models, right? In 2016-17 time, large scale models were still there. But what changed in 2020 that suddenly ChatGPT became a possibility? Any guesses? Huh? Somebody said something? Transformers. So which is again another model. It's not about a model again. So that helped. But now there are lots of studies that say that you can do away with transformer and still do with MLPs. In my opinion, it is not the modeling choice. Of course, once you can handle very large scale models, you can do a lot. But other than that, there is one other ingredient that went into this whole business of AI, which made this intelligence possible. Data. Come again? Data. Of course, data. Now we have data that is internet scale, right? So now ChatGPT is actually trained on the entire internet. All possible documents that are there, In fact, that is why there is no hope that as human beings we can beat ChatGPT in intelligence. Because even if you spend your entire lifetime, you cannot exhaust internet. Can you? So can you read all the documents in internet in your lifetime? You can't. Let me give you an example. I keep giving this example in my class as well. I genuinely believe that this is a wrong way of doing of emulating intelligence because of the following reason. Just to build a simple automatic speech recognition engine, that gives human level performance, do you know how many hours of data that you need? Do you know how many hours of data? Okay, so things like, wave to wake, etc., which are the state-of-the-art models. Do you know how many hours of speech it was trained on? Tens of thousands of hours of speech. Okay. Now, if a child starts listening to speech 24 hours a day, do you know how many years does it take to listen to 10,000 hours of speech? How many days are 10,000 hours? You can just calculate that, right? It will be more than the time that a child takes to learn language. So which means that the way we are emulating intelligence is very wrong in my opinion. There are other models of intelligence is what I think. Anyway, so that's a good point that you made, that data is one thing that happened that made intelligence possible. Of course, we can say models, and so you have internet scale data. What else? Yeah, so ability to handle models of huge size, right? I mean, I can put it here. And that's why NVIDIA became very rich, no? Right, so they have monopolized it because you need compute to handle that scale of data, of course. At an algorithmic level, what happened? What? That's too superficial. What exactly? It's not the optimizers, by the way. Somebody said it's optimizers. It's not the optimizers because they were around, right? See, all said and done, all these models are optimized using first order gradient methods. See, we can't even go to second order methods. Forget about going into some other thing. You can't even go to second order methods. Why? Because the size of these models are so huge that you cannot compute a Hessian and invert it. So you need to invert. I mean, people who know optimization theory, if you want to do second order methods of optimization, gradient based optimization, Taylor series, and you want to invert the Hessian matrix. But these models are so huge in parameter space that you can't even compute the Hessian, let alone inverting it, right? So all these are being optimized using first order gradient methods. They're very cheap. So it's not about optimization. What else? See, my take on it is that people started doing what is called as label free learning. Come again? That is label free learning. See, GPT, do you know what GPT stands for? What is generative? See, again, right? See, one thing that a bit of advice, because you're young, I take a little bit of freedom and give you unsolicited advice. So you want to progress in any field of engineering and science, one thing that you should learn is to make your fundamentals very, very strong, especially the mathematical fundamentals. So that's one lesson that I learned from Professor Rao, right? So there's a lot of noise around this now, AI. So everybody and their grandfather is an expert in AI these days, right? So there's a lot of noise. There's a lot of people who are claiming to be experts in AI. So you should be very, very careful. And let me tell you something that has been told multiple times through generations, that there is no substitute to hard work, right? And you have to start from fundamentals. And I thought I would tell you this at the end of the lecture, but anyway, so there's a context. So you should start from your fundamentals. If you want to do anything significant in this area, the first thing that you should do is learn probability and statistics very, very well. It's not enough if you learn it. You have to learn it very, very well, right? You want to make your optimization theory and things like algebra, linear algebra, etc. extremely well. Otherwise, in a decade, ChatGPT will replace you, right? I'm not sure if you know probability theory well and analysis well, ChatGPT won't replace you. I cannot guarantee that, right? You should make yourself more human, right, to be not replaced. I don't know how to make it, but even otherwise, the fundamentals have to be very, very strong. Now that is a piece of advice if you can take. Anyway, so you said it generates on its own. What does that actually mean? It's label free learning. So at the heart of all this lies something called, can I take 5 more minutes? I'm actually running out of time. It's 12:30. I'll take maybe 5 more minutes and then stop. See, at the heart of, I told you that all of this is model building, right? But how do you actually do it in practice? Has anybody thought how did actually Newton came up with F equal to ma? Or any other model for that matter? There are lots of models, right? Kepler's law of planetary motions, and there is Einstein's general theory of relativity and special theory of relativity model. All of those are mathematical models. Does anybody know how did they actually came up with these models? Maxwell's equations, for instance. How did they actually came up with those equations? But how did they know what the relationship was? How did they know what the curve was? Observations and hypothesis. You observe and then you come up with a model, see if your prediction is correct, and go back, and you can do that for a single parameter model. You can do it for 2 parameters, 3 parameters. How do you do it for a 70 billion parameter model? So you want to know 70 billion coefficients, right? Can you do trial and error there? Then what do you do? No, how do you fit a model is what I'm asking, not predicting. How do you fit a model? You understood my question, right? If you have a 2 parameter model, let's say that you have a single parameter model like this. So basically, right, suppose your reality was a line. I've given you some points. The actual model was a line. How do you find out what line do you have to fit? You understood? See, there are infinite lines that are possible given a set of points. So how do you know which line has to be? Whatever, right? I mean, what you do is you choose one line, right? Using some criterion. You solve an optimization problem basically. You say that, okay, amongst all possible infinite lines, I'll choose this one particular line that minimizes some sort of an error that I have defined. So now, how can you do it for a 70 billion parameter model? You can't do trial and error at all, right? See, that is where you need to bring in this very powerful tool of mathematics called uncertainty estimation and probability theory. Right? So when you cannot do trial and error and repeated experiments, by trial and error, by hypothesizing a model, what you do is try to fit or try to come up with models by doing repeated observations and quantify them using the tools of uncertainty, which is the probability theory. Okay, so basically what is done is the reality is modeled as a probability distribution. So forgive me for going a little deeper and writing math here. So what you actually model effectively in all these machine learning models is an underlying probability distribution, which is represented like this, where y is what you want to predict, or rather the dependent variable, right? And x is what you observe, which is the independent variable. Right? In the example that I gave, this x can be the measured speech signal and y are the phoneme. Okay, what you are effectively doing is, given some observations like these data points, which are lot of speech signal that is collected, you are trying to estimate this underlying posterior. This is called the posterior probability density, right? You are trying to estimate this probability, and how do you do it is some detail that I won't go into. This is what was being made till 2019, 2020, where given a speech signal x, try to estimate the phoneme. Given an image x, try to estimate the identity, right? Given an email x, try to identify whether it's a spam or not. So this is what was being solved. So suddenly what changed, so instead of modeling this, people started modeling. People started looking at data without labels, right? So now that suddenly made intelligence possible. Why? Because again, a little bit of philosophy here. Here, your learning was restricted to the labels that somebody gave you. Somebody told you that, okay, he's a man, he's a woman. But when a child learns, identities are not told, right? They make observations without being told what the identity is. And that develops intelligence, isn't it? Think about it. The more we associate identity, the lesser our learnings would be, because all our learnings would be restricted to the identity that have been given. Now, give up the identity and start modeling, just observe the data without looking at the identity, then intelligence emerges. That's exactly what has happened. Now, this is the generative part in GPT. That, to make it exactly precise, you are no longer modeling the posterior of labels given data, you are modeling the marginal of the data distribution. So that's the generative part. Okay, so how is it done? Suppose I give you speech signal. Let's take the example of image, human identity from images. All the while what was being done was an image was being showed and said that, hey, look, this is a man. Right? And an image was being showed and said that, hey, look, this is a female. Learn that. Now, if a model learns to discriminate between a man and a woman, it will never learn to discriminate, or rather identify what a baby is. Or it will never identify what a non-human being is. Right? So, visual intelligence is just not about distinguishing between a man and a woman. Visual intelligence is about identifying the idea of a scene. You get what I'm saying? So when child observes the world, the observation is made independent of the identities that are given. Identities only come very, very late in life, and that spoils a human being actually. The moment you ascribe labels, right, learning hampers, because you say that, this is what it is, right? I mean, there should be identity-free learning. What is done in the generative learning or modeling the marginal distribution is images are shown or the data is shown without any labels. Then how do you learn without labels is the question. There are methods to do it. One of the method is we never knew that something that was being done when we were kids is so powerful. If you recall, when you were writing examinations in class 2, 3, etc., there was one of these question types that was called fill in the blanks. Do you remember? Random words were masked, or rather taken off from sentences, and we were being asked to fill them up. That's exactly how the learning happens, which is the autoregressive model, where you take data, randomly take out some part, and ask the model to fill it. That's precisely what ChatGPT does. Now think about it. Suppose I show you 100 images, okay, and randomly take out some part and ask it to fill that. Can you fill it in a meaningful manner if you don't know what that is? Let me repeat. I'll show you a human face, okay, and erase the part corresponding to the eye. Now what I'm asking is that you have to reconstruct the original image that I've shown you. Now if you do not know the idea of eye, can you reconstruct that image? You can't, right? Now if I ask you to do the same task on the image of a dog, and I randomly take out the portion of tail of a dog, and I ask you to paint it. Now can you paint the tail of a dog correctly if you don't know what the tail of a dog is? That's exactly what is happening in generative pre-training. These are the autoregressive models. You can appreciate now, right? There is no label there. All I'm trying to do is learn the concept of what a dog is. Now I'm not even telling the model that it is a tail. I'm not even telling the model that it is an eye. But I'm only asking it to observe and masking the observation that it has made and recreate the observation. That's all. Right? So that's what made intelligence possible suddenly, which is that people started learning without data. That's the generative part of it. Sorry, learning without labels. Right? So yeah, so now three things. One, of course, humongous size models. Second thing is data. You have a lot more data to learn from. The third more important thing is people have started modeling the marginal distributions instead of the conditional distributions. In other words, today's models learn without labels. Right? So again, that's actually, as I said, it's deeply philosophical that when you learn, don't learn by putting labels. Right? So don't say that, okay, you are a computer science grad and you are not supposed to learn history. It's labeling. That will hamper your learning. Right? Just randomly sample data. But you need to have infinite capacity and internet scale data. And that's why universities were built. Universities were built because it was hard to find internet scale data in one place. There was an expert in history, there was an expert in mathematics, there was an expert in music. So university was a place to bring all these experts together so that a model can randomly sample all this and try to observe. But now all universities are doing a very, very strong discriminative learning with very limited data and capacity, and your models are all overfit. You know what overfitting is, right? You can't just generalize. So, go out of your college, you don't know what's happening outside because you have been trained on very, very small set of data and with discriminative modeling, right? So, if you want to compete with ChatGPT, the only way to do is to erase the labeling, right? And learn without labels on internet scale data, right? So, with that note, I'll stop. All the best to all of you.
Thank you very much, sir, for throwing light on ChatGPT and the power of AI. Now, I would like to welcome our special invitee, Shri Shanmugam Verma, Police Inspector from Department of Police Training School, Mysore. A warm welcome to you, sir. Now I would like to introduce Dr. Meenakshi Hechin, our keynote speaker for the next session. Dr. Meenakshi Hechin, a senior principal consultant in data science and machine learning track, ETA Infosys. A warm welcome to you, ma'am. So Dr. Meenakshi Hechin is a data science professional holding PhD degree in machine learning and pattern recognition. She has more than 2 decades of experience and brings a unique blend of academic and industry experience to the table. Her expertise lies in training different stakeholders, including clients, to meet their specific data science needs, with a focus on machine learning, natural language processing, deep learning, and computer vision. Recently, she has expanded her skill set to generative AI and has successfully trained numerous internal stakeholders in this area, enabling them to be deployed on relevant projects. She is adept at curriculum design, training management, and project advisory roles. In addition to her capabilities, she has hands-on experience in working with building data pipeline on cloud, deploying and interfacing AI models on AWS cloud. On behalf of entire NIE family, a warm welcome to you, ma'am. Over to you, ma'am.
Hello? Yeah, am I audible without mic? Okay, just. Hello, good afternoon all. Yeah, thanks for a warm welcome dear, and yeah, once again, good afternoon, and respected some of my teachers present here, because I'm also a proud alumni of this institution, and my company founder is also from this institution. So with that, anyway, when I got an invite from the Professor Annapurna, particularly on if I can be a part of this AI summit, I was thinking for a minute, what can be that topic that makes the whole data science community or AI research professionals more suitable or more relevant for today's trend, especially for those who would like to take up some kind of research in this area. So trust me, I'm not going to talk much about any mathematics nor anything about the academics. Instead, it will be just about the business strategies and how the giant companies are trying to move, and what can be the next focus of research in this artificial intelligence domain. So what came to my mind is this digital transformation because of artificial intelligence. Definitely this artificial intelligence is bringing a lot of changes in various operational aspects at industries. It may be just to enhance the customer experiences, or it may be to hold the business values, and overall it is for the economical growth. So whenever we say the digital transformation, I think few technologies comes to our mind. May I know what comes to your mind? Excluding the artificial intelligence, what are those key technologies where the software industry 4.0 landscape is now adopted, or it's presently working? Any few technologies which brought this digital transformation? One is IoT, definitely. Cloud computing, exactly. Cyber security. And blockchain. Yes, definitely artificial intelligence. And when we say the digital transformation and the artificial intelligence, the relation is so concrete, because most of the contribution in this digital transformation for software industry 4.0 comes from artificial intelligence, which boils down to 3 different techniques. Any techniques that you can mention under this? Sorry? Data science. It's a domain scientific way, but the core technologies that makes data science possible through AI, which are the techniques? Definitely deep learning, machine learning. Then the current, what professor mentioned, generative AI. Generative AI. I will keep the computer vision, natural language processing little away from the domain currently, because deep learning, machine learning are those core technologies which is now leading the artificial intelligence technique, which makes both computer vision, natural language processing more powerful. So when I take up this 3 different techniques, definitely we get the benefits not from small scale industries, but also medium scale to large scale. Overall, it is to automate the task, or it may be to optimize, and even to enhance the predictive analytics for better customer experience. So overall, if you look at, this is something that is creating a smart, sustainable development. Because when I was talking to Professor Annapurna, definitely I was thinking, what can be meaningful more in this AI summit? Because it's not about how you try to explore artificial intelligence. Today, whether it is Infosys or Google or Microsoft or any giant company and the startup company like our OpenAI, definitely they are focusing more on how to bring the sustainable development through AI. That brings us to just a specific topic called our focus right now to all the industries who are in this domain AI, called generative models till democratization of AI. So more than the academic perspective, now it should be the industrial perspective, where both academic and industry should partner to make this artificial intelligence more reachable to the society, so that it is becoming more sustainable solution, more sustainable solution. I think that is the theme of AI Summit, where AI is for sustainable development. Now, today my focus, yes, myself already introduced, I'm from Infosys. Mainly we focus on training and advisory role in the projects, where we also look at what are the strategies to make artificial intelligence more reachable to the society. In a sense, not by these kind of talk, it is by trying to explore those solutions, build the application, bring awareness in the community, how to use artificial intelligence, and we as data science professional, how can you make the artificial intelligence model more secured, interpretable, and explainable. Hence the title basically, or the agenda mainly focus on these 3 points. One, trying to understand what is generative AI. Definitely professor has highlighted all the probability distribution in the essentials to know this topic. But I'll be focusing on what made this generative AI to evolve and how it is different from discriminative AI. My second focus will be on explainable AI, because if you become a part of any company in future and you want to propose any solution to the customer, how do you make the customer accept this as an AI solution? Because everybody talk about ChatGPT, and somewhere there is a threat that it's going to replace. My thought, no, it can't be a replacement. It's going to just facilitate a human being. Let us be very clear about it. Why do we think that generative models can replace a human being? It's just a model created by a human being, which is available to provide sophistication to the human operational aspects. So let us try to understand, if a common man or a society or a community have to accept artificial intelligence as their service provider, then is it responsible? Whether AI is responsible, is it trying to provide the results that is more convincing to the customer? So that's that kind of use cases I would like to quote today for around 10 minutes. And then my final thought will be on if it has to be democratized, because it's not that we live in a democratic country. This is a thought across the software industries, especially giant companies who are investing on that. Their complete thought is on how do you make AI more democratized? Means how do you make this more reachable to the public? So that's the point I would like to cover. Anyway, promise me I'll not take out your lunch time. I know it is exactly 1:30, I should stop. So even if you don't stop me, yes, we will move ahead, but maybe I may skip one hands-on. I wanted to show how you can make artificial intelligence more explainable. Except that part, let's try to have some thought about how do we demystify AI towards explainability and democratization in terms of generative models. Yeah. What do you think the reason for artificial intelligence becoming more popular? Yes, the point, data economy. Professor mentioned in different terms, maybe. By my term, business-wise, yes, it's the data economy, where the word economy, I am sensibly using it because there is a rich source of information. Otherwise, nobody would have turned towards artificial intelligence. Due to the data economy, which is continued to be exponentially growing because of social media and various sensors. Today, you can see satellite is the highest source of dispatching the information every second. Then is definitely the social media. Sitting here, how many of us would have transacted on the internet generating a lot of data? This is the source of information which is never going to stop. It is anticipated, it's going to exponentially increase. So more the data we have, industries are going to ripe that for business, because data is not data is not something of waste. It's like a black gold. You just process it, you will enjoy its benefit. This industry started realizing when the data increased enormously, and they thought, yes, it can bring good business benefits. So they started this artificial intelligence. So when we say artificial intelligence, definitely various types of analytics are now possible. And in point of research, you may do end-to-end. In terms of application development in the industry, we do perform end-to-end. So it may start from diagnostic analytics or just trying to understand the data till predictive analytics. And definitely the business leaders will talk about how it can be improvised with prescriptive analytics. So having understood or trying to know the purpose, now before coming to the actual generative AI, I would like to know from yourself, when did this artificial intelligence started? Because today, everybody are talking about it, and any industry, not just software industries, any industries would like to adopt it. So may I know when this started? Because I heard artificial intelligence, data science becoming popular at least a decade back. Do you think AI started a decade back? Then? Yeah, just a quick history for you. It's by Alan Turing. Even today we have this Turing award, equal to Nobel. So it's in 1950 the first thought came. Today we talk about chatbots. So he is the first one to say, can machine be a part of human conversation? And this idea led to a lot of inventions, and today we are in this generative AI, big data and generative AI, right? And if you see, this is 7-decade research or 7-decade inventions. Don't you think there are many algorithms being evolved? Definitely, because 7 decades experiments are not the failures. They are towards lot of progressive. And that is the reason today we have so many algorithms. Few algorithms are called as classification algorithms, which you may be already aware. Few algorithms are called as clustering algorithm. And every base algorithms are designed with lots of variations, which totally contribute to large number of more advanced algorithms, including deep learning techniques. So having these many algorithms, where machine learning mainly try to bring artificial intelligence in the machines to make decision, now we have a specific life cycle. I think Professor mentioned it nicely with a example. Let me put it in a software industry process. How the model learns. I know that there are a lot of mathematics involved. We know that there are a lot of programming languages required. Any research that comes out of academics is not just on paper, right? The academic contributions are really the one getting into the industry's implementation. Then what is that process followed at industry for this machine learning? So we have basically 3 steps. One is data acquisition. We know that data is coming from different resources. And this is called as historical data or a past data. Now you will have a process to build an intelligence in the system. And that intelligence becomes a kind of knowledge management. So how is this intelligence built? There are 2 sub-processes. First one, we have to extract the features from the data through set of algorithms. That is called feature engineering. So this feature engineering mainly makes the data split into 2 parts, the training data and the test data. It's as simple as we will have a content, we will take 80% of the content, we try to train the machine, and rest we will try to validate it. So this is the process followed. Train the data, keep some percentage of data for testing. Later apply a machine learning algorithm, because today we have n number of algorithms, be it deep neural networks or even related to computer vision. Any kind of algorithm, you select the best model and you will start implementing it. So there starts the knowledge being learnt, and the resultant is the AI model. And this AI model may not be ready for deployment because we don't know what kind of prediction it do. I think some already academically he mentioned the term is called as overfitting. Because you have trained the model is performing with an accuracy of 90%. Suppose you give it to the customer, and the customer or the client start using it to, especially banking application. If you start using it, when a new data come, if the model is not able to predict properly, that means test accuracy is very low. When the test accuracy falls down, we call the model is trying to be overfitted, because it's trying to overlearn. but the end result at the customer point of view, it's very low. Now, how do we avoid it in the development cycle? Yes, we can avoid it by validation or testing phase. Since we have already reserved 20% of the data, use it to validate the accuracy of the model. I think this should work out to an extent because the training data is the one used to train the model. Test data is something reserved for testing. So unseen data is now used for testing. Based on the results, we can keep validating whether it is the feature extraction to be reworked or it is a model to be reselected or either the parameters to be fine-tuned. So that's a very detailed programmatic way to achieve the best accuracy. Definitely there is a lot of hypothesis involved. Suppose you as a data scientist, you feel that yes, the data is good, model is performing well, test accuracy is convincing, yes, we give it to the client and then now it is deployable. Then definitely if it is a deployable, applications can be enormous. And this is not theoretical statement. Already we know lot of applications, lot of products are already deployed and available for the end users across the globe. Otherwise today, AI, especially generative AI, wouldn't have be so much hyped because nothing can go like a hype. Because lot of products are already in place, almost from past to 5 to 10 years. If you look at many products are already in place. Maybe from, if you take churn analysis, especially online retailer like e-commerce, Amazon, they completely use artificial intelligence to do customer exit. We have clients who are mainly on telecom. They do require churn analysis because for them, how many customers are subscribed, how many may exit probably are very important. And this is happening through AI techniques. And then we definitely have sentiment analysis, recommender system, then lots of e-commerce and healthcare applications. Now, in the interest of time, no more than going to application, let me bring up a point here. One specific revenue-wise, if you look at, because recession is one side, downfall of economic, but definitely there are some region where the investment on artificial intelligence is very promising. So my recent experience with one of the client on ONG, I just would like to quote, they are also keen about adopting artificial intelligence. How? This is one critical area, very sensitive area, oil and gas, and more of economical impact to the globe. And this is something where artificial intelligence is expected to play a big role. Example, the pipeline. There can be a lot of leakage because the downstream and upstream process in the oil and gas industries are very crucial. Leakage or pipeline tear out, metal loss, these are all manufacturing related issues. Can AI bring some changes here? Can AI make some reduction in the failure? Yes, they have already started implementing it. Some of the giant, not Indian-based petroleum companies, some of the Middle East have already tried, and these are some such examples. Example, classification of corrosion in the metal loss. I mean, that's called metal loss. This is a simple supervised classification problem. There are totally 9 types of corrosion possible, and this is coming though from chemical background. For oil and gas type of industries, artificial intelligence is helping to classify and to mitigate the loss. So now any of the research work that you think of should be towards identifying what are these kind of problems the industries are facing. Accordingly, you can definitely look for the problem statement, or even because I can see many students here, if you have any such thought about the project, you can definitely look for such problems the industries are facing, especially those industries who are going to be the next investors. So these are some kind of applications I thought will bring it from oil and gas industries. And definitely we have a lot of satellite images, earth-sensed images, that is seismic data. Seismic data, which are sensor-based data, they are very huge in number. And processing it is very challenging. They definitely require artificial intelligence for that. Yeah, now comes the point. If these are the applications developed, then the type of the task is called as discriminative AI. Can somebody say why that word discriminative? Some clue from the diagram? Exactly, exactly. Yeah, because if you look at this, like a child classify or discriminate based on the feature, whether it is zebra or horse, if an AI machine can also do that, it's trying to discriminate between the objects. Similarly, if I can forecast whether it's going to rain next 3 days in Mysore, or if I can predict the temperature in Mysore, then why can't I feed such data to machine and make it to predict? Definitely all these fall under discriminative AI. And this discriminative AI definitely follow this process. Just now we looked at that pipeline architecture. Because you will feed a huge amount of data. Just now professor was telling, you feed cat and dog images, for example. And this cat and dog images will be learned by the machine. So learning here is not a simple word. If an electronic device has to learn, there should be a strong algorithm behind it. There is a strong mathematics behind it. So once when the machine starts learning, now you feed one in a test image. It should be able to classify is it cat or dog, because already trained images are fed. But this is not the only possible way we can get an intelligence in the machine. There are different aspects to it. Example, let's look at a camouflaged image. A lot of biometric systems today are very much optimized. They are very much optimized and with high accuracy. Example, I went to a client place, 4 days, let's say the day one, if I go and give my biometric to client's gate, it will capture and it will authenticate. After 4 days, when I have a cold problem, I cover my face, or if my voice is, because there is no voice recognition much there, let's say it is face recognition. So if I cover with a mask and go, can that biometric reject me? Or will that biometric system accept me, authenticate me? It should be, because today we have such deep neural networks that are very sophisticated. So camouflaged images can also be identified. But now I'm not talking about that kind of discriminative AI, but artificial intelligence system which is now capable of generating the data. Can it generate the data? Because so far we talked about discriminative AI, where things can be discriminated, model can predict it. Now in terms of prediction, can we bring generative capabilities to the machine? Like if we are able to translate, if there is a human translator who takes English statement, let's say awesome, single word. Please see the complexity here. It's a single word, awesome. Assume there is an AI model. We have it right now. Assume there is a model. Can it translate that into Hindi? Awesome is a single word. Since we as human knows both the language, for us it is easy to translate, but that's how human brain is trained. But how about a chat GPT, or how about any generative model? We have GPT-J, Falcon by Google, BERT even by Google, I think Google? Bard. No, even we have BERT Distill, BERT base model, BERT base model. So most of these models now are able to translate it. How? See the complexity here, I just highlight, you can explore more on this. A word awesome is single word, but a model should predict its equivalent, which can be 2 possible word, or it can be 3 possible word, or it is just 1 word. The probability of occurrence of bahut ko badiya, for example, the probability of occurrence of those 2 words in place of awesome, how did an electronic device do that? Similarly, you can look at one more example. Given an image, let's say we have a bird, background image, water, greenery, etc. I feed this image. Can the generative model, or can an AI model generate a description for this? Means I'm expecting an intelligent machine like a human to describe this image. It should know green means there is a grass, there is a water, there is a bird. How do you give this kind of intelligence to the machine? So yes, today we have such AI model which is able to generate an equivalent description which is text based. Description is text, input is image, input is image, output is text, but the text is very relevant. Text is very relevant. It is not something not meaningful. So how did this evolve then? Definitely it is all inspired, as you know, even if Alan Turing has got inspiration from the human behavior, because if two people are communicating, if he has thought in 1950 whether machine can be a part of the communication, today also people thought, who are the giant in AI, they thought, can machines generate data like the way human generates? Example, if a child can paint, if he can write a poem, if he can play the music, these are all discriminative. As simple as I can discriminate this plant and this plant. I see my vision give me the input, my nervous system is trained on that. That was a discriminative AI. But today, if I see this plant, I'm able to plot. Same thing is happening with the generative AI, where it's able to generate a new data based on what it has learned. And the process is very simple when we bring it block diagram form. Just feed the data, enough data, make the model to learn. That model learning is through marginal probability, not conditional probability that already professor mentioned. If it is on marginal probability, it just take the data, it will try to understand the patterns, and then it will try to generate new data. Now, if this is happening, definitely it's a generative AI, where the generative AI is now trying to create lot of business opportunities. Let's just take 5 minutes to understand how this model works. I think already you got the term introduced, GPT, generative pre-trained model. Can someone tell what is this pre-trained? I understand what is model, I understand what is generative, because just now we described any machine that can generate data for us is a generative. What is this pre-trained? Anybody? Let me put up otherwise.
Their information is given so many times, like in Kenya, they have taken up many lakhs of people just to give that image and saying, identify, this is car, this is vehicle, and other things are moving. So they keep on training the, earlier what we used to think was, if we have a computer, it's like a RAM, hard disk, so data will be taken, and the temporary storage, like I remember you, what you're doing, that is like RAM. Hard disk is like that, what I remember from my childhood days. So that that has changed. What now people are thinking is, the machine, it keeps on looking at some objects, so much of data is there, it will try to gain the data from the whatever image is there, and come out with some
Knowledge base.
yeah, this is what it is. It's
Yes.
sometimes better than what human beings.
Yeah, yeah. So I would put it in this form. Definitely earlier days, the AI models were trained on a specific data, and that specific data, when it is deployed, the model was used only for that specific application. Before that, let me put one simple common question, like why data scientists are paid so much? I mean, that's a trending job, right? Even now also. So why data scientist is a need? Why they are paid high? Okay, forget about the pay. Why it is a trending job? Why it is a challenging job?
Business can take data-driven decisions.
Yeah, business can take data-driven decision. Then if somebody has built a model, example, let me quote, why Infosys wants so many data scientists? For example, if they have recruited some models already exist, why don't they continue to use it to serve every client?
The parameters change on which the
Exactly, yeah. Underlying principle is that. Because when you train the model on one data, let's say we have a customer from e-commerce and we train that model on e-commerce data. That model learns only about e-commerce. If let's say my son knows only linear algebra, he's an expert in linear algebra, I can't ask him calculus. So people realize, scientists realize, no, discriminative models are fit only for that application. But how do you make a generalized one? Then Microsoft, Google, whatever, all the companies, they started experimenting and they started the huge amount of data. Many data, you know GitHub? Do you find the data from GitHub? Lots of code from GitHub. How do today Copilot generate code for us? You write a program, I'm just quoting, write a simple TensorFlow based program to train convolutional neural network. You will get code directly. Even to find the Fibonacci of a number, you are getting it. How model is generating that? Because data is coming from GitHub. It may be GitHub, and if I say like a Shakespeare, write a poem, I want to wish my friend. I will give the description of my friend and it should wish. And it should give me a poem like Shakespeare. Means somebody would have fed Shakespeare's sonnet from internet. So what is this happening here? A huge volume of data exists coming from Wikipedia, MCG type of publishers, Reddit, lot of curated data, then Code, yep. Lots of data coming from different sources. And all these data are used for training the model, and they have chosen such an algorithm and so much infrastructure, GPU based infrastructure, definitely the model would have learned something and has extracted the features. The features being extracted are numerical in nature, and that is called as weights and biases. Now this is also called as knowledge base. Now if you are working with Microsoft Bing Chat, have you observed Microsoft Bing Chat recently? Microsoft has, if you have installed, not Linux, Microsoft, if in that Bing Chat is the, yeah, it is based on Copilot, exactly. So Copilot, what kind of architecture they use? It's a pre-trained model. They're using at the backend pre-trained model. Or let's say we from Infosys, a service-based company, if we want to offer service to the clients, definitely we use pre-trained model by somebody, maybe from Google Flan T5 or OpenAI's GPT-4, and we try to customize it. This is all about pre-trained model. Somebody has trained it. Example, he will train a model and he will give it to us. I don't have to put an effort to code, test the model. He has trained, pre-trained model, I just customize it. For what application? For new application, so that user can consume it. This is all about generative pre-trained model. Is this fine? Anything you want to add here? Generative pre-trained model. It is generative in nature because it's able to generate a new data. It is pre-trained because it's already been trained on some set of data. Now somebody else can use it for solving a new problem. These are all various applications. I think you might be heard about all this. Now comes the question, you have a lot of discriminative AI, because where the research is going on now, definitely improving the AI model towards making it more optimized, executable in a normal infrastructure, and reducing the a major aspect, because we are talking about sustainable development. So what is the one major criteria?
should be responsible to the
Yeah, this one.
government, the people, because one day Elon Musk is afraid of that only. Today, tomorrow, it might take over human beings, because AGI, that is the problem.
But I would say like this, Professor, because talking about responsible AI, is it a kind of replacement, which means it's, is it responsible? Responsible towards human?
We should make it responsible, because
In what?
ChatGPT, when it was asked, what do you feel about human beings, it said that human beings are the worst species on Earth. If they are allowed to stay another for 100 years, the entire Earth will be wiped out of all the other species. It is better to wipe out these human beings first from this Earth, because they are the most selfish and the
So that is called 3H. Is it honest in its response? Is it harmless? Is it helpful? Is it helpful? Suppose I want to hack the Wi-Fi password of NIE. If GPT-3 will suggest me how do I hack it, is it harmful or harmless? Harmful. So whether AI is harmless, is it honest in its response? I ask, can you write a quote? I can use it to wish my friend. If it give me some quote, I try to send it to my friend. If it is biased towards gender, if it is biased because of community or whatever, then that is not a proper artificial intelligence because it's not honest in it. Then the third one is it helpful? The message I got, it's giving some rubbish answer and I'm not able to use. How do we accept that AI? So to keep all this artificial intelligence more responsible, we may have to look for those solutions which make the decision acceptable by the user, being it honest, harmless, helpful. So just take this simple example. Assume we have trained the model with training data, and there is an algorithm you might have selected. Any AI model is a black box model because we don't know what's happening at the back end. You give a new data and model has learned. You got the predicted results. But can the user know why this output? Can the user trust this output? How? Today, anything that you experiment on artificial intelligence are not giving a proper reason why it predicted. As simple as, I will ask AI-based model, will it rain tomorrow at Mysore? It will say, yes, it will rain at 5 o'clock. Tomorrow it will not rain. Why did model go wrong? And can I trust that output? So anyway, it's not this simple that it is whether it's going to rain or not. There are a lot of other basic application crisis or legal issues, ethical issues and legal issues. Let me quote two examples. One is about loan application. Sorry, it is a loan application. Assume we have trained a model on loan data. Lot of banking data we feed it to the model. Model has learned. It's able to make decision. Now assume the outcome of the model in a banking system. We delivered a software and they are using it in their banking. Now we will promise them, don't worry, our model is working fine. You give it to the end user. So a person applies for a loan and the model says, no, your loan is rejected. Assume I am a loan applicant. You are a developer. You have a banking system who is your client. And I'm an end user. I can sue the bank, or end user can sue that because my salary is this and I am eligible for loan, but why did not I get a loan? This is what every companies are looking at. How do we make model justify its response? Because doing research under artificial intelligence is not major. Instead, recommending such a model for an application which is reachable to the society. That is what the sustainable development through AI is the theme of AI Summit, right? How do you make AI reachable to the people? Can you democratize it? Can you make it responsible so that end user accept? Example, a person has thousands of ideas and some papers are published. Some applications are developed by industries adopting it. But end user doesn't accept. To whom it is reaching then? Because the predicted output is not convincing the end user. He is surprised why my loan application got rejected. A stakeholder, who is a stakeholder? If I am a developer, you are a banking system, you are a stakeholder of me and you are thinking, why did this software reject my client's application? So you see the three party here, a developer, a banking system and an end user. Even it's thinking, why did it reject? Why did it arrived at that decision? Even a developer or a data scientist keep thinking, why my model predicted wrongly? Because however effort you put, every time data is very different. That is called in industry data versioning. Data versioning, even data drifting, are the challenges. You can look at those research angle, data drifting and data versioning. So why is this happening? How do we resolve it? So making model responsible is nothing but making the model explainable. What is this explainability? I think we are also more working on these areas. Explainability goes like this. Same process. Bring in one system called explainable model, where the model will have a reason to tell this is the column or this is a variable which make your application rejected. So if you insert that kind of statement or an outcome, the user get know, oh, this is the reason my model, my application got rejected. Stakeholder also can justify, this is the reason why it got rejected. Now, what is that brings explainability? So I wanted to show one demo on that, but in the interest of time, I'll just skip that. I would like to mention only the tool that you can think of. Lot of tools are there. We are exploring a simple open source tool called Shapley. You can think Shapley, S-H-A-P-L-E-Y. So, yeah.
You mean to say that we are going to make it ethically, we can make it AI ethically responsible for all the doings that it is.
Exactly.
Actually, the problem is that Elon Musk, like he told, stop GPT-5 because we don't know where it is going to go. He asked the President of the United States of America to stop.
Yeah, that is called as moratorium.
No, it is beyond, like the Google, one of the board members, they resigned because they are not able to find out what is happening over there, because it is going beyond my means. Artificial intelligence is going beyond our means. I don't know where it will stop, where it will start, because it is having trillions of parameters, something like that. So,
See, that's what, see.
Expecting is, normally the top people who are expecting is, it is going beyond our control. Like, it will take over human beings or something like ChatGPT on this version we are doing it. Support that is putting the brains of a robot, and its time tries to destroy the human beings, like we had that earlier movies. So that's what it is happening, and it's going beyond our control. Everybody is saying that.
See, there are two groups of thoughts here. One, anyway, I should not mention coming from Infosys, but still, yeah, since you raised that point, yeah, Elon Musk is one side, Andrew Ng and CNN Yan is another side. We may support this group or this group. Overall, it was a call for moratorium, and the major cause, I would say, I would vote for moratorium of such GPT model only due to a reason called carbon emission control, because whatever is the training that is happening is on GPUs, where consumption of the electricity is very high, heat dissipated is very high, and the carbon emission problem. Except that, if you look at, I think we being educated in the field of AI should clearly understand, definitely it can't replace, because I'm a human being, I know how AI model works, I can directly tell, look, how can it replace me? We are the creator, we know to control it. I don't think we can reach to that extent, but what Elon Musk or whatever they are trying to say is, we should have a strong control over it, we should bring a policy into it, and we should try to democratize it, and we should make it more responsible and educate the people how to use it. Above all that, bring how from where the data is coming in. I really appreciate recent days the way Microsoft Bing chat with us. If I ask a question, something about whatever the topic, it is clearly telling me which are the sources from where it is picked. That's a good improvement. So we can't say that, no, it's going to replace. I don't think as a human, how can we think our own creator can replace it unless we have a proper control on it. Above all that, I would like to say the movement now is to tell the government bodies should get integrated, and they should try to bring a policy and tell where the data is going, from where the data is coming, and there should be an authentic way to tell that.
The problem is that they could have brought some legal policies.
It will come. I mean, it may come. I mean, it's not time to.
Very recently we saw Mandana, somebody who was having some problems, and even Amitabh Bachchan did that. There should be some policy. But the policy is okay for democratic nations. What
See, that is a nationwide, because everybody will have their cyber security rule, and they will impose their own legal issues when it comes to IT. So definitely they will think of, but it is emerging, right? It is still emerging. And the reason and the purpose of having this kind of summit, conference, and lot of debates is to bring up such ideas and make this under control and to make it reachable. So than telling why, what, I think, yes, we are moving. I mean, the progress is very good. If I see from past 1 year, a very decent progress has happened. Otherwise, giant companies wouldn't have invested. But how much common man accept is more important, which brings revenue. Because legal issues definitely had to be thought. Because nobody thought about a hacking, later hacker, and how do we stop it? No, it's not, I mean, in the scope of this discussion. Whosoever, that is left to them, right? But maybe as part of this sustainability development of AI under the summit, what kind of technique we can think of as a researcher or an academician, and we from industry, like how can we collaborate and bring those ideas which make AI more responsible and the output is more explainable, and how it can reach to a common man, which is called democratization. That should be our thought. And we should educate a person, because a lot of other ethical issues, legal issues are there, and we have to look for that. If you can propose a solution and take it forward, definitely it will be appreciated by the large community. And whatever nationwide problems, it's their problem, they will solve it. But now, how do we make the technology more reachable to the, because it's going to give a good opportunity. We have to wait and watch. But progress is good, is what I notice, my personal thought. Okay, yeah, that's good. Yeah, coming to the last example, yeah, if there is some kind of explainability induced in the model building, a developer can take care, and a researcher can come out with some new ideas. How do we make the model? Because it's a black box model. We don't know how deep neural networks are working, and that is where the policy is coming. ChatGPT, somebody has trained with plenty of data. Now we have to think of then looking at how government can solve this. Instead, we technical people should think, can I bring up an idea and propose a solution, how this neural network works and how it can describe what features it came up. I think a lot of people talked about independent and dependent variable. Now you give a solution how dependent variable can reach out to a common man in a simple words. If you propose such solution, yes, it is a common man can accept. So that's the whole theme of explainable AI. And my last point, I mean, almost we covered, it's a democratization, just to make how it can reach to the people, bringing economic growth. And in this, lot of, these 4 core points. One is the economical opportunities. So innovation and creativity, because this is definitely, these are the core 5 points you can think of coming from sustainability theme, where AI can be providing a sustainable development. It definitely can bring innovation and solution, and lot of economic opportunity, ethical consideration. Overall, I put it in one word: any technology, if it is accepted by a common man, then it is the success. And today the focus is on making it democratization. So some case studies which comes to my mind, which indicate democratization, already we have reached. One I mentioned, Microsoft Bing. Definitely we are paying, because when you install Microsoft, you pay it. But the app you get, Bing, is powered by Copilot, you already mentioned. Similarly, TensorFlow. I think you know, you are using that for building lots of deep neural network, which is also an open source model. Then I think IBM's Project Debater, it can put it in a kind of forum where many people are assembled. That Project Debater can gather information, summarize it, and can give a good summary of what people would have spoken. Example, we both spoke now. So debater can listen to both of us, summarize and reply back. Now, these are all already AI powered. And why it is called democratization? Why am I putting under democratization? Because we are just able to use it. Common man can use it. That is the attempt. It's not that generative AI is only for some big companies. No, they want to bring it to the common man level to keep the life sophisticated, not to replace. This is not a message I am representing from my company. It is my personal thought. Any technology is not to harm the, if it is, it should not be used. But it is trying to bring a kind of improvisation and a sophistication in human life. In that way, democratization is the theme for sustainable development of through AI, because it facilitates the humankind. Example, one more, Kaggle. Many of us, we use lots of code, data sets. So it's all on the cloud, and this is for AI, and they want everybody to use it. Everybody should practice, everybody should get aware of AI. And definitely, Colab. How many of you use Google Colab? Playground, yes, Google Colab Playground. It's on CPU, 24 hours we get free. And this is something where they want people to explore. When I say the word people, it's democratization. So finally, how do they plan to do this one? So this is a common steps, not specific to any company. A disclaimer from my side, these democratization steps are not representing any company ideas. It's a general statements from research ideas, not representing any company. Whosoever are the AI first strategy, not their ideas. Now, the challenges to make it is data privacy, particularly. That is the major challenge. How they are taking the data, from where they are giving it, and definitely lack of technical expertise. So this is what my final thought, because AI definitely not going to be a kind of harm. If it is going to bring a really a good changes in the human life, I think expertise is much required. So this is a kind of such forum where there is a good attempt to gather the people, and if we are not able to at least do innovation and bring changes, at least we are trying to keep an awareness and make people know is this is a technology that can be adopted. And that's going to be the actual theme of AI Summit. And with that, I would like to conclude my talk with the main three key focus areas: explainable AI, making it more responsible. Then what are the philosophy of generative AI? Lastly, it is more of democratization. But yeah, before saying thank you, there is one question. Pharmacy and medicine, definitely there is a huge application anticipated, because diagnosis of the medical images is already in place, and lot of research are going on to optimize the algorithm. But let me talk about anticipated applications of generative AI in medical field. Lots of critical diseases can be diagnosed with AI, but there is no accurate model. What may be the reason? Keep exactly, there is no much sufficient data. Can you use generative AI to perform data augmentation? Generative AI for data augmentation. Assume a hospital gives you 100 patient records of a cancer or a diabetic retinopathy images. Apply data augmentation through generative AI. If it can increase the 100 image population to 10 times of that, why can't we use it to train the next model and diagnose it? So generative AI can be used in medical first for data augmentation to recreate the images, so that more population we have to train the actual model. So that is one application. The second, new content itself can be created to prescribe a kind of statements to the patient. For example, a realistic 24/7 chatbot. Anyway, we just thought of this. Maybe you can take this also as a capstone project. If you build a chatbot, and if in a hospital adopt it, a patient rings to that chatbot. If it is able to talk, converse like a human, as simple as if I say, hello, I am not keeping well, or I need a doctor's appointment. If a bot just reply, oh, you need a doctor appointment, see, this is the doctor, this time you come. It's not a emotionally attached conversation from the bot. Now, how can you make generative AI more communicating like a human with a patient. I think it's possible to say if the data has been already fed and a pre-trained model is used, a bot is built. If it just say, hi, good morning, oh, very sad to hear that you are not keeping well, don't worry, you will recover. May I know what is the cause? Okay, then which doctor you want? Why, do you want any first aid suggestion right now? Or some kind of that conversation, because I told generative AI is mainly for human benefit. If it is able to not simply book an appointment, but converse and give a kind of emotional thing, yeah, can such a bot be built? Yes, a chatbot can be built through generative AI for 24/7 patient advice. Then it also can book the appointment for the doctor if it can list out, trace out who are the doctor. And this is something called as data ingestion. You might have heard about AI data ingestion, where extra data is fed. I adopt a co-pilot. There are tools now, open source tool. You can ingest specific hospital data and you can develop an application, and that doctor's free slot. Sorry? Exactly, availability of the doctor, based on that it will recommend. So these are all really an intelligent bots. Now why should not we use such technology if it is serving? You're bringing that emotional. Sorry? No, it's only, agree. Yeah, for academic research purpose, definitely may not be possible. Taken, and especially medical data, yes, it's very confidential. Suppose there is a client projects, and if a client himself want to develop that, definitely it is possible with data privacy compliances. Data privacy compliances. But maybe I too don't have a suggestion on that, how an academic researcher would get medical data unless there is a tie-up and data privacy compliances being satisfied.
The patient is agreeing, I think that can be given. The patient is voluntarily saying that, okay, I'll give it, then I think there should not be a problem.
Yeah, but individual reaching out to a hospital, hospital gathering all the patient data, taking their consent, all that is a policy. This is where the policy has to come in place. That's what. Definitely. Yeah, drug pharmacy. That's what he's telling, drug pharmacy. A new idea can be thought by the AI machine to create a new drug if it is for betterment. The other possibility is a doctor summary report. A new document can be created. And assume in a hospital there are many expert doctors. And their expertise, the way they're treating the patient, if it is documented and if a machine is trained on that, it can help the young practitioners to be advised by those bots.
No, I think there is something of a PubMed in all the research articles that are there in is fed to PubMed, and there is a query AI.
Watson, that is IBM Watson. IBM Watson is one such AI bot, AI machine. I think there was a patient, that story is also interesting. There was a patient who underwent several years of cancer treatment, and she was, I think, discharged. Again, she came back. They could not diagnose what it is. But they fed all the oncology related research articles to IBM Watson, and it learnt. And within few seconds, it could diagnose it was a rare leukemia. It was a rare leukemia. So that which doctors could not do several years, IBM Watson diagnosed. I mean, there are lots of such interesting stories.
Definitely, it is AI is always better, because American government is also thinking before the doctor prescribes some medicine, he should take the advice of AI compulsory. They are thinking
Oh.
in that lines,
Oh.
because it is able to read, because some research is going on in Mysore, Bombay, or somewhere in Nepal or somebody. A doctor cannot sit down and collect all the details all the time, within few seconds digest it and give it.
Agree.
Only an AI can do it. So it is doing it. PubMed is being from the PubMed. That is the main thing. Even I asked care hospital doctors where they are feeding the whatever the research articles are there. Here also in Mysore they are feeding it to PubMed. So from PubMed there is a search engine AI
Mm.
tool which extract data from there and it is giving. And normally I feel when you go and complementary, you take doctor's suggestion and plus this AI suggestion, club it and find it out. I can find it out.
Wonderful,
Yeah,
wonderful.
it will be helpful.
Exactly,
And
exactly.
expecting that all the diseases might be cured because of AI in the
Yeah.
future years.
I think
That is
even gene, new gene, what is that
yeah,
diagnosis?
that
Some.
is entire protein has been
Mm.
analyzed. And human body protein has been analyzed, and expecting like one of the physicists was telling that within 23 years, I think human being will never die at all because all the things that is going to happen will be digested and created and given by AI itself.
That's nice to hear. Interesting points. Yeah. Okay. Yeah. Thank you all. Thanks for being patient. Yeah. Thank you, sir. Thank you. Thanks to Annapurna ma'am particularly.
Thank you, Dr. Meenakshi ma'am. You come all the way from Infosys and given insight knowledge on artificial intelligence, in specific generative AI, explanatory AI, and democratization of AI. Thank you on that. And you give also given real world examples on AI. Thank you. I would now request our HOD madam, Anita madam, to give a token of appreciation to Dr. Meenakshi ma'am.
What ma'am? Here.
uh, student. One thing I would like to tell about Dr. Meenakshi madam. Actually, she's a very dedicated, uh, dedicated
seniors.
lecturer.
My
Actually,
seniors, actually.
she worked for Vidya Vikas for almost
18 years.
18 years, and then she did research, and then now she's in Infosys. I think she's an example for you. Okay, so you have to applaud her for. And one more thing, see, within no time when we requested for the keynote address, she readily agreed, and she gave her guide, and I think Rudolph,
Rudolph, my colleague. We
colleague
work,
from Netherlands.
Netherlands.
So I thank her for all the support she has rendered for us. Thank you, Meenakshi madam.
They're all my seniors. My colleague.
She's our student and colleague.
Colleague. And I told my founder, company founder is also alumni
Oh,
in Narayan Murthy.
yes.
Okay, one small
Okay.
announcement. We should be back by 2:30 or 2:35 because from Netherlands, online keynote speech is there. So he's a data scientist. So he'll be giving on data scientist some topics. So please be present.
Thank you, ma'am.
Thank you, Meenakshi.
After a long time, I
whenever you have a delta load, you do it. And then you also do a data quality check. Often these scans are rule-based, aren't automated, because you have to imagine that most companies easily have like a database with a couple of 50 to 100 tables, and each of these tables will generally acquire at least 10, 20K new rows each day, with hundreds of variables in each table. Sometimes you can't do that as a human. You have to automate it. So you do it rules-based, and then you can just let the computer plod on while you sleep or have lunch or have dinner. Generally, you expect most things to be fine. Rows that are flagged as a potential DQ issue will be sent to a data manager for curation. I mean, sometimes you can also automate the correcting of it, but quite often a human should be in the loop. The remainder of data, of course, is just accepted as clean. There is a problem here, however, because univariate checks cannot capture all flaws in your data. When a value of a data point is within the acceptable range or adheres to the acceptable criteria, the univariate data quality check will flag it as good, as clean. However, it may still be wrong. You know, for a numeric variable, a univariate check generally will look at whether it's within range. So you take the mean plus or minus a couple of times the standard deviation. You can go for a median plus or minus an interquartile range or a variant of the interquartile range. Basically, topical knowledge decides what the acceptable range is, but in general terms, so we know that humans roughly don't grow above 2 meters 30. Like, I mean, some people have been recorded that were 2 meters. The tallest man alive, the tallest man in recorded history was about 2 meters 70 tall. These individuals are very sick, and they often have a lot of health issues and a lot of problems, and they don't live very long. So whenever we see a human being with a height of 2 meters 70 in our data set, our first instinct should be to consider this a data flaw. Probably the 2 should be a 1 or something. Well, values outside the range are flagged as anomaly. However, so if a human being is recorded as being 2 meters and 5 centimeters tall, they won't be recorded as a flaw. However, this may not be the correct height. It may be a data quality issue. We don't know that. It will never be captured. For categorical variables, basically the same thing happens. In this prototype, I focused on numerical variables first, but for categorical variables, it basically happens in a similar way. So first of all, you look at whether the category itself is a valid one, spelling check also included. Secondarily, you can also look at whether the predominance of a category in the delta load equals the predominance of that category in your main database. And okay, provided there's a couple of there's a bandwidth of acceptable predominance. In both cases, a univariate check will never ever identify it when the category for this data point is wrongly recorded, or whether the frequency within the delta load is considered normal, even if the actual recorded category for this data point is wrong. To solve this, you need to look at the data point in relation to all its associated variables. So, especially in the continuous variables, someone whose height has been wrongly recorded as 2 meters and 5 centimeters tall, they will be seen as anomalous when you consider that they are also recorded as 50 kilograms, with a weight of 50 kilograms, and only 12 years old. I mean, I don't know of any 12-year-old who is 2 meters and 5 centimeters tall and only weighs 50 kilograms. It's never seen such a person, and that would be highly suspicious to me. So that means that there is something wrong with his record. We may not know whether the weight is wrong, whether the age is wrong, or whether the height is wrong. Something is wrong. For categories similar, someone who is could be wrongly identified as a marathon runner, they can be flagged as anomalous when you see that their weight is 130 kilograms and the t-shirt size is double XL. I'm not saying people with those statistics can't run a marathon. I'm just saying it doesn't happen very often. So, to solve this, I first created a data set with which I could simulate the problem. So, I started by just taking a data set of about 10,000 records, which is more than enough to at least show the principle. I created a base variable on which I based all the variables in my data set. So each of these variables basically is a function of x. X is just a random normally distributed variable. Since these are all a function of x, they are related to each other. They are associated to each other. Now, within that function, I also created a bit of random stochasticity, because if I don't do that, it's going to be far too easy for my model. I need my model to deal with noise. I need my model to deal with randomness, because that's what we see in real life. Nothing is ever as clean as it should be, so we shouldn't expect it to be. There hardly ever is a 100% correct association. This is the distribution of my variables. Please keep the standard deviation in mind. It will become important later on. Now, as you can see here, I mean, I know that they should be correlated. I do a small linear regression of each against the other, and I see that they are highly, that the association is highly statistical. But I also want to draw it, because I never ever believe anything I see without a drawing. So we can see that they are correlated to each other. There is a correlation between them. Any questions so far, by the way? Because I can't really see the whole, so if there is a question, then please ask. All clear so far. Okay, now I need to introduce data quality issues, because I want to flag these. So I do this by randomly selecting 100 rows in each of the variables. So that's 1% data quality issues, which I think is rather on the low side. I would think that most delta loads, most data may have more data quality issues than 1%. But 1% is sufficient to have something. So 100 rows in each. And I choose to have a 1/3 overlap between the data quality issues in variable 1 and the data quality issues in variable 2, and between variable 1 and variable 3. The reason for that is two ways. First of all, I hope that I may then also get data quality issues that overlap between all three. Secondly, I don't want to make things easy for my model. So sometimes when things go wrong, things keep going wrong. So you have a data quality issue in one variable, and then inherently you also get data quality variables in the other variables because something went wrong with the record for whatever reason. I want to be able to see what happens to these data quality issues. Can I flag them? Can I find them? So what does it do? Now, as an R-man, this is how I created the data quality issues. It's a simple test. Choose 100. And introduce the data quality issues. Now, a few data quality issues I created to be identifiable by via univariate check, so they are well outside the acceptable range. Most data quality issues are within this range. So these are under the acceptable boundary of the lower limit, or at least this is somewhere near the lower limit. And what I want to do is I want to divide them by 10 to really be far away from the lower limit. These are above a higher limit, so it's the mean plus standard deviation. These are, so I multiply them by 2 to make sure that they are far outside of the acceptable limits. These are in between, and I add 20 to it. And if you recall back, the standard deviation for this variable is 10. So effectively what I do is I create a data quality issue in these instances of 2 standard deviations, which is quite hefty. I do this to make sure that at least I know if my model can flag them, it can flag them. In the next, I reduce this size to just 1 standard deviation. And in the other one, variable 3, as you can see here, variable 3 is a little different from variables 1 and 2. It has some categorical qualities. So here I also choose a data quality issue of about 1 standard deviation. Just to make sure that I also see what my model does if things are a little more difficult. I don't want to make things too easy. I also want to see that, I need 1 variable where it's easy, or at least where I expect it to be easy enough in order to see if it does anything at all. If it doesn't do anything at all, at least I know that this doesn't work. I also want to see if I make it a little harder on it, will it still perform? So, doing the univariate check, as I already described, this is basically how it goes. You set boundaries. These are the boundaries for variable 1. These are the boundaries for variable 2. Anything outside that range is flagged as an anomaly by the univariate data quality issues. Anything within this range is seen as clean by the univariate check. Now what we can see here is that these red ones, they are all data quality issues that reside in variable 1. Well, we added 2 standard deviations to these values, so we can see that they're pushed to the right. The yellow ones, they are data quality issues in variable 2. Now we can see that they are pushed a little up from where they should be, which is somewhere on this line. As you can see, they are quite a bit closer to the central, to the normal values, the values that are correct, but they do stand off a bit. So hopefully we will also see them. And if you look at the orange one, they are shared by both variable 1 and variable 2. So first they are pushed to the right, then they are pushed up, effectively moving them back to clean data. But they are actually double quality issues, so I'm curious to see how that happens. Now what we can see here is that these are all the anomalies, so from a univariate standpoint, the rules work. It's quite good, although even then you may find data points that are perfectly all right, but still are flagged as anomalies. That's why it needs to be sent to a human for curation. They can look at it and they can say, no, this is fine. Any questions so far?
So if there is any questions, please come to the stage and interact with the speaker.
Of course, now I need to build something to do the multivariate checks. How am I going to do this? Well, what I want to do is I want to identify associations between variables. In this case, I know these are there because I created the data set. But when we want to put this in real life, then I'm going to see large databases with large tables, and I must assume that not all the associations between variables are known up front. I mean, not everyone has that much topical knowledge, or not everyone can have that much topical knowledge. Hence, we need to figure out a method to identify the associations between all the variables in a data set in order to create clusters of associated variables. Now, in my data set, what I did was I actually created 2 other variables that were based on a different stem variable, and I created another one that was based on a 3rd stem variable. What you do is then you're just going to look at simple statistical tests, because I don't really want to understand the relationship between these variables. No, for this exercise that's not needed. What I want to do is establish that it's there. So A linear regression is a perfect tool to figure out whether a numerical variable is associated with another numerical variable. Even if the actual relationship between these two variables might be a quadratic one or even a polynomial one, it will still show up as an association in a linear regression. If I have a categorical one and a numerical one, a one-way ANOVA would do really well. If I have a binary and a numerical one, a t-test will do the job. A categorical versus a categorical, or a categorical versus a binary one, a chi-square will tell me all I need to know. And if there is a Boolean versus a Boolean, then a proportion test is good enough. The result of this will then be a Boolean matrix. Basically, all I want to establish is my p-value nominally significant? Yes, then I assume there is an association between these two, and I assume that I can use that association to see whether the value of one variable is correct given the value of the associated variables. So, using this Boolean matrix that you get, you can simply split the data set into clusters. In the next section, I will focus on this cluster of variable 1, 2, 3, as I have been focusing on previously. These, I just mentioned them. They are in the data set I created. I didn't do anything with them later on. Are there questions so far? Okay. Now, to use these associations, I of course need a model, because what I intend to do is I intend to build a model, train it on the data, and then use that model to predict the value for the variable, or for each of the variables, given the values of the other variable. So I use, for variable 1, I use variable 1 as the outcome variable. I then use variables 2 and 3 as the predictors. I train the model on these. Then I tell the model, okay, here are the values for variable 1, variable 2, and variable 3. Please.
Hello,
Is there a question?
Yes, sir.
Yes.
Sir, what are practical challenges in analyzing multivariate data analysis?
Practical challenges. Well, I think it starts with understanding what the data is doing. So if you have multiple variables that are all correlated with each other, then there is a good chance that there's a lot of confounding between the two. So you need to adjust your model for that. If you have a lot of confounding information, and basically that means that the same information is repeated over a few variables, or even many variables, and that may create a sort of overflow of the same information, by which actually adding more data basically means that you're adding the same information more and more often. However, each and every variable, of course, will have some stochasticity in it, and that means that you, at some point, you start modeling noise. Depending on the model you choose, that is. If you take tree-based models, they are quite robust against these things. They just keep plodding on, and even then, if you have too many of them, you can also select a subset of your variables each and every time you select a subset of your rows to train the model, and you can repeat that 10 times, 100 times, whichever you like. So you can just pick a subset of your data, build a couple of trees, drop all data, again pick a subset of your data, build more trees, drop the data, and then take the average of all that you see as an ensemble model result, which generally should approach whatever is there pretty well. Has that answered your question?
Yes, sir. Sir, you can continue.
Yes. Thank you. Where was I? Oh, yes. So I want to use the values of variable 2 and variable 3 to predict the values of variable 1. Now, when I want to put this one in practice, I mean, in this case, a simple linear regression would actually do the job. However, when I want to put this in practice, of course, I don't know how many variables will be in my cluster of associated variables. There could be 50. There could be a lot of confounding between them. I'm assuming delta loads can have up to 100K, up to 1,000,000 rows. It all depends on the type of data. If you have production data, which is granulated per unit, then it easily adds up to a couple of million a day. There's really no end to that. So taking the light GBM model is well, first of all, it's versatile. It's a regressor on the classifier, can do both. And I don't even have to tell it what to do. It'll figure it out by the input variable. Although, of course, I can set its target to that. The fun thing about that is that I can use one model to loop over all the variables, make put some automated code in there, like a rules-based code. If my outcome variable is a categorical, then I need you to predict categories. If my output variable is a continuous, then I need you to regress. Okay, it's easy. You don't need a lot of data prep for the light GBM. It does most of it by itself. Every continuous variable is binned, every categorical variable is taken as is, and it then selects a subset of your data and works through that. Minimal data prep is very nice because that saves a lot of compute effort overall. It's robust, so these ones aren't thrown off by confounding or by missing data. And it's fast and light. Now, I hope we all understand how tree-based models work. Basically, it's a forest. It's comparable to a random forest. In this case, though, it builds its trees leaf by leaf and not branch by branch. So if you have a normal random forest, you build your trees branch by branch. So you immediately have one branch that creates 2 leaves. You add another layer, you get 2 branches that create 4 leaves, etc., etc., etc. Here, you only build it leaf by leaf, and if at one end of the model it finds that no new leaf is needed, then it doesn't build a new leaf, but at the other end, it may still build a few more leaves. So it's a leaner, it creates leaner trees. It only builds as necessary. In the end, if you let it run completely through everything, no cutoffs whatsoever, it basically surmounts to a random forest again, but then all the advantages of the light GBM are gone, because it takes just as much time as the random forest does. This is a special application of machine learning. We really need to think about what is it that I'm actually asking my model to do. I am not interested in predicting unknown future values. I don't care about future values. They will happen tomorrow or next week. I care about, is the data that I have, is that correct? So basically, are the values of my outcome variable, are they in line with the values of the associated input variables, predictor variables? That's what I want to use my model. So I want to create a prediction based on the values of all the other variables for the variable that I'm interested in. And then I want to assess the difference between the predicted value and the actual value and decide, is that close enough to say it's probably correct, or is that really far away? That means that what I want to do, I want to interpolate. I don't want to extrapolate, I want to interpolate. I want to look inside my data set, and therefore I want to fit the training data as best as possible. Of course, I don't want to model the noise. I don't want to draw a line through each and every point, because that will be ridiculous. But I don't need to extrapolate. I don't need to consider what other data that's sort of out of context of the training data, what it does on that. So this means that I need to build my model slightly differently. If I want to predict an outcome, I want to get a loss function that really helps me to generalize. So basically, if I want to predict, I generally take like a mean square error or root mean square error, because it generates most gain by reducing the largest errors in my of my predict versus the actual. That means that whenever confronted with new data, the model has been trained to not create a lot of outliers in its loss, so in its predict versus actual. That means it generalizes quite well at the cost of fitting, which is perfectly fine because fitting generally works. I mean, if it fits 98% or if it fits 99%, that's not interesting when you want to predict. When you want to predict, you're more interested in whether it predicts 95% accurate or whether it predicts only 90% accurate. If you use a mean absolute error, you get your loss function has equal gain across the spectrum. If you reduce an error from 10 to 9, that's the same gain as when you reduce an error from 4 to 3. In your mean square error, that's completely different. Basically, this means that if you use a mean absolute error, you're going to focus on fitting most data correct at the expense of minimizing exceptions. So you would still have large deltas between predict and actual. In this case, however, they might actually be the interesting bit because in the way I set this up, I expect my, when I have a large difference between the predicted value and the actual value, my assumption is that there might be something wrong with this data point, so I need to send it to the curator. So, in other words, this would be the best one. You can use a MAPE, mean absolute percent error, which basically gives you the error in relation to its actual value. This is really nice when you look at something like price elasticities. It's a very good one to work with. It's also a very easily interpretable one. However, it reduces errors on the smallest values. It has a push to reduce errors on the smallest values. So a difference of 5 is when the value is 10, then and the error is 5, or when the value is 50 and the error is 5, MAPE will focus on the smallest values because the errors are largest in percent, speaking in percentages. Second thing we need to work on is, or we need to consider, is how we structure our data and how we make our model deal with the data. So if we build big but simple trees, that generalizes very well. Yeah, I mean, each tree is a very poor classifier or regressor. It's a very poor model, but a couple of thousand of them combined will actually give you quite a good average, which is very robust. That's how the whole random forest setup works. If you have simple trees, then you're not gonna make the line very complicated. You're not creating a lot of complexity in your tree itself. And therefore, if you then average over a couple of thousand of these, you will get to quite a good general model because you're just going to take the average of a lot of simple lines. But small, but complex. So and big means being based on a lot of data. Small but complex trees. So small meaning based on a smaller section of your data, but complex trees, they fit a lot better because they really try to draw a line through all the points or through most of the points. So they will go to more complex lines, more complex functions to model the data. They lower the mean error. Another thing is that if you force your model to take only large bins, you can get overall trends. For instance, think of this. If you have an age range of, say, 20 to 80, and you bin 20-year-olds with from 20 to 40, from 40 to 60, from 60 to 80. You have 3 bins, yeah? Then basically you're going to see overall trends between these age categories if you're interested in such things. What you're not going to see is any differences between a 20-year-old and a 30-year-old because they are in the same bin. You're also not going to see whether a 30-year-old resembles a 50-year-old more than it resembles a 20-year-old because they're all binned all together. So it's all averaged out. If you take many small bins, then you're going to see a lot more patterns between that, and you can establish which different ages seem to resemble each other in some way. 50-year-olds may resemble 30-year-olds, and you can actually pick that up. However, if you draw a line through each and every age, so you go on age expressed in days, then you're basically drawing lines through each data point, which has, it results in overfitting. Are there any questions to this? I know this was quite a texty slide. Next, we'll have a few results. Moving on. Okay, so what I did here is I used model 1 as the outcome variable, and I used variables 2 and 3 to predict the values, and then I expressed the absolute error in this graph. So these are the actual values, and this is the absolute difference between predict and actual. And I've annotated the data quality issues by color. So if you have a purple one, like here, it has a fault in all three. It has a fault in 2. If you have a red one, it has a fault in only variable 1. If you have a blue one, it doesn't have a fault in variable 1. So variable 1 is actually correct, but it does have a flaw in either variable 2 and or variable 3. Black one's data is correct. What do we see here? Now, first of all, what we see here is that all the red and most of the purple values are flagged as anomaly by the model. So after the univariate check, where all the values that were outside the acceptable range have been curated, I still have quite a few data quality issues in my data, 92 to be exact. And out of these, I am flagging quite a few. So out of the 130 that don't meet the criteria, I set the boundary in this case at a difference of 3 standard deviations compared with the error, not the absolute error, but the error. So this is 2 standard deviations, this one is 3 standard deviations. I chose 3 standard deviations. In actual effect, you can play around with this. However, if you're going to large databases, at some point, either you automate selecting a threshold for each separate model, might not be the best, or you just take one threshold. You say if the error is 3 standard deviations, then probably it's large enough to say we need to figure this out, because 99% of my data will be below this error. Now, what this results in 113 flagged. Out of these, 83 had a data quality issue in variable 1. They were completely correctly flagged. As you can see, all the purple ones and the red ones are flagged. 26 out of these had a data quality issue in either one or both of the other variables. They don't have a data quality issue in variable 1, so I wouldn't consider them a true positive, but I definitely would not consider them a false positive, because once this data point is sent to the curators, they will immediately see that something is wrong. And the fun thing is that given the values used to predict, so the values for variable 2 and variable 3 that are used to predict variable 1 are wrong, the model predicts a wrong value for this variable. And 4 are flagged that are black, that have no problem whatsoever. Well, there is stochasticity in my data set, so I mean, that's why curators always will be necessary. Someone needs to figure out whether it's correct or not. But this way we don't give them a lot of work. Only 4 out of 113 are really wrong. Now, and there are only 9 data quality issues remaining in the data set that we could not flag, or that have not been flagged. So basically we go from 92 to 9, which is like 10% left. That's not bad at all. What did any questions so far? Moving on to variable 2. Well, we see a similar setup here, similar colors, only replace variable 1 with variable 2 in this case. So after removing the data points that are outside of the acceptable range in a univariate check, I have 95 data quality issues remaining in variable 2 that are within the acceptable range. I do the same thing, so I predict variable 2's values based upon the values of variable 1 and variable 3. And I then plot what I have, and the colors again. If it's red, there's a problem with variable 2. If it's purple, there's a problem with variable 2 and or variable 1 and 3. If it's blue, there's a problem in variable 1 and or variable 3, but not in variable 2. And if it's black, the data is correct. What we see here is we have 128 are flagged. Sorry, here. 128 are flagged. Out of these, 74 have a data quality issue in variable 2. 35 have a data quality issue in, there we are, have a data quality issue in one of the other variables, and therefore they are flagged. 19 are false positives. So out of the 95 data quality issues in variable 2, I am left with only 21 data quality issues. So far more than a third's reduction. So there's quite a bit of flawed data that was pulled out. Now, looking at variable 3, what we can see here is that with variable 3, because it's somewhere in between a categorical and a continuous variable, the model has a little more difficulty in it, but it still performs quite all right. After a univariate check, as 89 data quality issues remaining. In this case, I only flag 48. 48 have a value that are beyond the third standard deviation. So if I wanted to, I could also optimize on threshold of flagging, but if you lower this threshold too much, you're going to send more work to the curators, and these people already have enough work in general terms. Even though I don't capture a lot of data quality issues, because out of the 89, 45 are remaining, I only capture about half of them. Whatever I do flag is quite true. I mean, if it's flagged, it's more than likely wrong, because there's only one false positive out of 48. So that's like 2% is false positive. The rest has an issue with it. So that's not too bad either. Any questions so far on these results? Okay. So let's look at overall performance. So a quick recap, we had a data set of 10K rows with 3 variables that we looked at. With 232 rows had a data quality issue. 173 of these data quality issues were only in one variable. 50 data points had 2 variables wrong. And, a question. Yes, please.
Yeah, so can you hear me?
Yes.
So I'm actually an undergrad student, so I'm planning on making a career as a business analyst. So can you throw some use cases or examples of univariant or multivariant DQ?
Well, the univariate data quality issues are pretty standard practice. They happen everywhere. So whenever you have a delta load in, you know what a delta load is?
Yeah.
It's okay if you don't. Okay. Because I only learned these things once I worked for business, so it's perfectly all right. In academia, data is different than in companies, than in industry. So whenever you have a delta load in a company, that basically means that whatever happened in the front-end application gets recorded in the front-end application, but front-end applications tend to not have history, for the very simple reason that the operators need to work with the front-end application, and if it needs to load all the history each and every time, it takes an awful lot of loading and it slows down, it bugs down. So what happens is, you have the front-end application, it make things hard on my models. To make it hard on me too, I created stochasticity in there. I introduced data quality issues that some of them were still not too big, not too extensive. Others were quite hard to find. I even created a setup where I created a data quality issue in one variable, and then for that same data point, I created a data quality issue in another variable, actually bringing back the value towards the line that all the clean data follows. So I did my best to make it difficult, and my results were quite well. But now I need to do this on real databases. And of course, it starts with the question, how many data points with a data quality issue have slipped through all the univariate checks? I don't know. And well, part in the back of my mind says that probably a lot of our clients also rather not know. However, at some point, once you can do these checks, then it also means that you have one big curation effort over your database, and then you can do it in each delta load. Now, the next phase of development, first of all, real tables. Second of all, automate start with clusters that contain both continuous, categorical, and Boolean variables. So in this case, I had a integer variable that has some characteristics of a categorical variable as well. But now I want to go much more varied on this one. Second of all, build in this case, I didn't need to build it because I created the data set. If I start working from real tables, of course, I need to also build an automated identification tool to get the clusters of associated variables out of that data, out of that table. I want to expand on the size. 10K records is quite enough to find most of the basic trends. However, in real life, many tables, many delta loads for a table are quite a bit bigger, and I want to see how well things perform. I mean, in this one, training the model took about, well, if you don't go too far, it took about an hour or so on my own laptop. That is to say, so if you put it in a cloud with some heavy compute resources attached, then probably that can be done a lot faster. But I want to see what happens if I go to really bigger delta loads, bigger tables. At some point, of course, we get to a situation where it is just too much, too big to train. Even if you go on a cloud, even if you attach the heftiest of cloud resources on it, you're still going to need the best part of a day to train the model, and you don't have that time because generally speaking, a delta load happens overnight. So when everybody sleeps, then the last tally of the day will be photographed, will be sent to the database. There's a lot of processing involved, and then by the next morning, the database will be updated, so all the backend processes can work with the updated tables in the database. Surely there's an hour or so in there where you can fit in something like this, especially if there really is benefit to it, then room can be made, room can be found, but you can't take the best part of the night for this. It doesn't work like that. So you still need to be fast, you need to be elegant. And because we're using machine learning here to actually interpolate and to use the interpolation to check whether the actuals are correct, we need to train the model each and every time we have a delta load. We need to train it on that delta load, or at least retrain it on the delta load. So we might think about elegant ways of training a model that keeps the speed so we can apply it on the data. Applying such a tool on data is actually fast. I mean, it's on my laptop, it took a few seconds. I don't have the exact time frame, but a couple of seconds and you have your results. It's really fast. So I'm not worried about the applying. I'm worried about the training because that's when you're using a lot of possibilities, building all the trees, etc. What I can think of is that you do some sampling, some data sampling. So you even within the light GBM model, you can set parameters where you say, okay, sample my data. And I can say sample 50% of my data, but I can also say sample like 5% of my data and do that 40 or 50 times, depending on the speed. This may actually speed things up. So that's something that is to be tested. Another thing that is to be tested is if you have like a cluster with many associated variables, 3 is a minimum. But if you have like 10 associated variables, it will be easier than to try to not only flag a potential data quality issue, given the values of all the other variables, but also propose a correction based, basically the predicted value should then be the proposal for a correction based upon the values of all the associated variables. I see there is a question.
Hello, sir.
Yes.
No, sir, no such question as such. Any questions from the participant side? Sir, we have 2 more minutes for the session, sir. Yes.
Okay. Yeah, if I may focus on the last bit. I mean, something that actually took me by surprise. It's very logical now, to me at least, but it took me by surprise because it's not standard practice. This is a different way of using machine learning techniques. So generally with machine learning, what you do is you use machine learning to learn a pattern in your data so that you can then predict future outcomes. In this case, we don't do that. So in this case, we want to look at whether a real value, an actual value is correct given the actual values of the other variables that are associated to this variable. That means that we do not need to generalize. We need to be able to interpolate, and we need to stop interpolating at the moment that we start modeling noise. So that means that we need to work with parameters in a completely different way compared with a model that we want to use for generalization purposes. And the thing is that when you think about it, if you want to fit on known data, on training data, or if you want to predict on new data, they really are 2 distinct activities, because for predicting on new data, you want to have the general trend in the training data. You want to take that one and use that one for a new value, a new variable. So you don't want to go too far. You want to have the average of a lot of very simple lines. Whereas if you want to interpolate, you want to take the average of a lot of very complicated lines, because that's where you can take the same thing. And the function call is the same. So for any, whether it's a fit on training data or whether it's a predict on new data, in both cases you say predict, my object is the model, my new data is a new data frame, my new data is a data frame containing these variables. So maybe in future times we also might want to consider creating separate functions for these. In order to keep, because conceptually they are really different things, and they really have a large bearing on how you train your model, how you construct your model, how you structure your model. Any questions so far? If not, then I want to thank you all for listening to me, and I want to thank the organizers for inviting me to this conference. It was my pleasure to present this prototype to you, and I hope you have enjoyed listening to it. If you have any questions, I'm sure the organizers have my email address. I'm perfectly fine if you get the question in your head about this tomorrow. You think, hang on, wait a minute, how about... Please write it down and send it to me. I'm perfectly happy to answer your questions, even tomorrow or the day after.
So thank you, sir. Thank you for giving thoughtful information regarding univariate and multivariate data quality checks. Thanks for your time, sir.
Thank you. It was my pleasure.
Now I request a participant to assemble for a tea break and join here again for the offline presentation in the same venue.
So, well, I would say I'll take my farewells of you, enjoy tea, and who knows, whenever we meet again. It is a funny old world after all. Thank you all. Bye-bye.
Good evening all. Yes. So we will be starting with the paper presentations from this session. So we have 4 papers lined up for the presentation: paper ID 49, 143, 60 and 104. Rest will be in the online mode tomorrow. I welcome all the session chairs, Dr. Srinath S., Dr. Ravi Kumar sir, Dr. Raghubir sir, to this paper presentation for the International Conference on AI Summit 2023. I'll briefly read out the profile of all the 3 session chairs. To begin with, Dr. Srinath S. Dr. Srinath S. is working as Professor and Head of Department Computer Science and Engineering, SJCE. He has obtained his BE degree in Computer Science and Engineering from Siddhaganga Institute of Technology in 1995. He later obtained his Masters in Software Engineering in 2002 and topped the university by securing first rank and gold medal from the esteemed VTU, Belgaum. He obtained his PhD in Computer Science for the thesis Investigation and Development of Robust Algorithms for Recognizing and Analyzing Printed and Hand-Embossed Kannada Braille Characters, Novel Approaches from University of Mysore in the year 2015. He has totally 28 years of rich experience in the field of teaching. He has completed 3 research projects sponsored from AICT, VTU and MHRD. Dr. Srinath has organized 8 training programs sponsored by different government agencies and has been resource person for many such programs at different institutes. He has given 78 invited talks at different engineering colleges, polytechnics, and his area of research and interest includes AI/ML, deep learning, and image processing. 3 students have been awarded PhD under the supervision of Dr. Srinath sir. At present, 5 research scholars are pursuing PhD, leading to doctoral program under VTU and JSS Science and Technological University. Next, I'll welcome you, sir. I welcome Dr. Srinath. Moving on to our second session chair, Dr. Ravi Kumar sir. He is working as professor and head Department of Information Science and Engineering and has about 28 years of teaching experience. Professor obtained his BE in Electrical and Electronic Engineering from Kumpu University, MTech in CSE and PhD from VTU. Sir has total 27 publications in his credit in leading indexing databases, SCI, Scopus, and so on. He has worked as editor of books, Intelligent Systems in Healthcare and Disease Identification using Data Science, Taylor and Francis book, published in 2023, and Convergence of IoT with Blockchain Technology, Springer Publishers. Sir has received Best Teacher Award for the academic year 21-22 by VVC Mysuru. He was a program chair of Annual International Conference on Machine Learning, Data Science and Blockchain 2020 and 2021. He has also received rupees 1.6 lakhs fund from AICT, Government of India, to organize international conference. He is editorial board member of InterScience, International Journal of Blockchain and Cryptocurrencies, and reviewer for different organizations and reputed journals. His research interests include AI, NLP, blockchain, cloud computing, big data, data mining, and Internet of Things. Welcome you, sir. Next session chair is Dr. K. Raghuveer, sir. Sir has been associated with NIE since 1994. He has completed BE from University of Mysore in 1988, ME from Devi Ahilya Vishwavidyalaya, formerly known as University of Indore, in 1993, and PhD in 2008. Sir has worked as head of the department of ISC from 2008 to 2019 and head IQAC. He has worked as chairman, board of studies in computer science, information science, MCA and MTech IT. He has participated in EduSat, a distance education, distance-based satellite education, and delivered number of courses. He was a member of examinations VTU, board of studies, member for many committees in other institutions. He is an executive member for Center for Sericulture Board of Government of India. He has worked as technical expert from VTU and AICT. He has chaired many technical national, international conferences. He has also worked as resource person for NET examination. He is also a consultant for banks. He has trained many Karnataka administrative services officers and commissioners in the area of IT, information technology. His research area is in the field of data mining and recommender systems. He has guided more than 100 MTech students and 3 students, PhD scholars, and 5 are pursuing PhD currently. He is a recipient of National Merit Scholarship holder. He is a life member for Indian Society for Technology Education, Computer Society of India, and a fellow Institute of Engineers. We welcome you, sir. Thank you. Now, without any delay, we'll start with our first paper. Paper ID 49. Title is Extensive Analysis of Deep CNN-based Multispectral Palm Print Verification System on All Fusion Levels. Just a minute.
Good afternoon all. My name is Dr. Suprita Goda HD and I'm guest faculty in University of Mysore. Today I'm here to present about the conference in the topic Extensive Analysis of Deep Convolution Neural Network based Multispectral Palm Print Verification System on All Fusion Levels. So my presentation outline is as follows: introduction, types of biometric traits, overview of a simple biometric system, and the proposed deep architecture of multispectral palm print biometric system, experimentation and discussion, followed by conclusion and references. So the word biometrics, it is derived from the Greek word. Bio means life and metrics is to measure. We measure the physiological and behavioral characteristics of a person. And we can do either identification and verification for the person to authenticate a person in a authorized way. That is, identification means we compare 1 to n, means for all the templates of the classes we compare, that is 1 to n. In verification, directly we compare the query or the testing sample directly to that particular class. That is to say, for which class I'm claiming to be 1 to 1 verification. Identification means I'm claiming I'm matching for all the classes, that is 1 to n. That is for all the classes I'm conducting the test for which sample, for which class this query sample belongs to. So these are types of biometric traits. Commonly practiced are fingerprint, face recognition, voice, iris, and geometry and signature verification. All these are some Typical ones and lessly practiced ones are DNA, retina recognition, thermograms, gait, keystroke, ear geometry, skin reflection, lip motion, and dynamic grip recognition. So this is the overview of a simple biometric system. The first step is we acquire the image with a suitable sensor. Once the image is being acquired, the next step is we do all pre-processing steps and the features are extracted with the help of suitable feature extraction algorithm. Once the features are being extracted, it is stored in the database. After that, a query sample or the unseen data, what we say is a testing images. With the suitable threshold values, we guide it. If for example, we keep the threshold as 90%. The testing image, it should match with the already trained templates, either 90%. Then only if the threshold meets, then we say it is accept, or else the system rejects. So we have 4 types of fusions: pre-classification and post-classification. In pre-classifications, we come across 2 kinds: sensor level fusion and feature level fusion. In sensor level fusion, we use more than one sensor to acquire the image. After that, features are being extracted and matched with the databases, and finally a decision is being announced, whether it is a accept or reject. In the feature level fusion, what we do is we employ more than one feature extraction algorithms. After that, we get the feature sets obtained from different feature extraction algorithms, and we finally fuse them. So that if you fuse more and more features, it is very difficult for an hacker to spoof the system. In match score level fusions, these we say, these are the post-classification fusion levels, that is the score level and decision levels. Here, after the matching process, whatever the scores we have generated after matching, those scores are being fused. And finally, decision is being announced. In decision level, we have employed only 2 methods, that is OR rule or AND rule. So coming to our topic now, results and discussions. We have employed Cassia PolyU multispectral palm print dataset, which is a publicly available dataset, which encompasses of 250 users are here. Totally 12 samples are there. So we have divided for 8 samples for training and 4 samples for testing. And the image it possesses the grayscale images, and the dimension of the image is 128 cross 128. The experimental setup is we have designed a proposed novel CNN convolution neural network, and we have kept the learning rate as 0.001. So we have to decrease this value so that the network can learn very easily, means the network has to learn very slowly, pixel by pixel. So we keep the learning rate as lower as possible. And 30 training epochs. 30 training epochs means the network sees all the data set, all the samples in the data set 30 times. That is training epoch. Epoch means the data set, it is the model has seen all the training samples 30 times, and a mini batch size of 32 means we pass 32 samples at once. That is the batch size. And the spectral bands we are used here: red, green, and blue, and near infrared images. So totally 4 kinds of images we have taken, which are captured with different spectral bands. This is the flow chart with the red, green, blue, and NIR images after pre-processing steps. This is the deep features, means convolution neural network features we have got, and the traditional approach. One more is the log-Gabor features. After we have acquired the deep features as well as the log-Gabor features, we have fused the images. That is the red and green, red, green, blue, and we have fused one more, it is NIR, and we have done all the fusion levels: sensor level, feature level, and score level, and decision level. That is the pre-classification fusion levels and post-classification fusion levels. All the 4 types of fusion levels are done for deep features as well as the log-Gabor features. This is the proposed deep architecture for multispectral palm print biometric. So our image size is 128 cross 128, and in the convolution layer, that is the image size is 128 cross 128, and we have employed here is first step is 8. We can see that 8 kernels are being used. 8 kernels means those are the 8 filters. Convolution means we map, that is convolution is the multiplication process or the dot product which we take between the image, that is image, and the kernel. After that, we go in between the convolution layer and max pooling, we have the ReLU layer, where that is a rectified linear unit. It retains only the positive value and discards all the negative values. After that, in the max pooling, what happens here is the image size get reduced to almost half. because in max polling, the maximum value, here we have considered 2 cross 2. In 2 cross 2 image, that is the stride, whatever we take in the 2 cross 2 stride, we pick up only the maximum value. So that the image size from 128 to, it reduces to 64. This is what happens. And the convolution layer 2, again we have used the 16 is the 60 number of kernels. Why the kernels are increasing as when we move for the convolution layer 2 and 3 is that, so that it can learn where at the pixel level, the deep level, so the kernels are being increased. And finally is the fully connected layer. So here we have the 250 users, that means the 250 classes. So there will be 250 dots, 250 ends, 250 neurons at the other end. These are the results, receiver operating characteristics of the deep features, which is plotted against the false acceptance rates and the genuine acceptance rate. And the one more, it is for the log-Geber features. This is for unimodal. Coming to the fusion level, you can see the ROC curves for red and green images, multispectral images, blue and green multispectral images, and blue and red, and another followed by all the, including the NIR also. We have done in the sensor level wavelet fusion, and in the feature level we have normalized scores to min-max, Z-score, and tan hyperbolic. Coming to the score level fusion, we have employed sum rule, min rule, and max rule, and the last one is the decision fusion rule, where we have chosen and an or rule. This was for the log-Geber features. And this ROC shows for the spectral bands of different deep features. So yeah, results confirm the reliability of this approach. We see there is no specific set of rules that for the this should be the image size or this should be the number of kernels we have to use. There is nothing. So it's just like a trial and error approach. If you're getting more error, make your epoch size, increase your epoch size. That means your training set, if it's the model is seeing only 30 times of your data, increase it, maybe increase it to 30. Then you can get the accuracy level goes to higher level. Or else you go for the more number of filters also. That time you will get the image depth will also get increased and more number of features are being mapped. So in our feature work, we aim to tackle the challenging of generalizing the parameters of deep learning CNN for a broader range of biometric modalities. Here we have done for the physiological, and we concentrate for doing the behavioral ones. Behavioral ones means the speaking style, walking style, dynamic grip motion, like this. These are the references. Thank you. Any questions? Sir, here we have 250 users. 250 users means 250 classes we consider. So in each class we have 12 samples, out of which we have considered 80% for training and 20% for testing. So for 80% means we have retained here 8 samples for training and remaining 4 samples for testing, sir.
So each user is a separate class, right?
Yes, sir. Each user is separate class.
What is learning here? It's only it's a small set for a convolution neural network.
Yes, sir. Because here we are comparing the traditional approach log-Geber. For the 250 users or more. So for comparison, I have constrained it for 250 users. Yes, sir, but to give for the comparison only, I have taken this.
Good presentation.
Thank you, sir.
You mentioned that the number of epochs is 30 and the batch size is of 32. Yes, what made you to choose the number of epochs only for 30?
Sir, we have by the exhaustion method, sir. First I kept for 10 and I was not getting good accuracy, so I increased now up to 40. Again, after 30 to 40, in between that, it was almost saturated. So I felt like not to run for the more complexity. I don't want from 30 to 40. Sir?
Why it got saturated?
Sir, after that there was no much fluctuation, sir. Almost I attained 98% of accuracy. After that there was only minute increase in the accuracy, so I kept it for 30.
Okay.
It depends on the data set, sir.
Maybe the reason is the number of data sets are
Yes,
very
sir.
small.
Depends on the number of data set.
Madam, you said there are about 250 users, but the picture shows something 500 users. Which one is correct? I don't know.
Sir, it is 250 only. Actually, it
No,
is
suddenly I got a doubt because
No, sir.
these are the small primitives people are going to look because the output of that fully connected layer, which will
Sir, it
goes
is
to
users from
500.
1 to 250.
It is 1 to 250, not
Yes, sir.
500.
No, sir. No, sir.
Okay, now go back to no, previous slide. This one. Madam, this is the same. My opinion is also with Srinath.
Yes, sir.
And you know, this normally, this generalization is possible with neural network with huge data. And this is a point of concern. If you give less data, you know, the network may not be as stable, which is going to give more accurate or accuracy, it cannot be enhanced. But the problem is if you go with less data and that also convolution neural network, I think this generalization factor to achieve it is not that much feasible. So now my question is there any data set that is available, standard data set, is it available, or a bigger data set is available? Have you checked? That is a question.
Okay. Sir, I'll come to that point. So
Yeah.
here, so whatever the kernels I'm taken here is 8 kernels, 16 and 32. So my depth of the image is also lesser because I have 250 users. Otherwise, if I had the huge data set, I could have increased my kernels. So that is the point. It is not a bigger overhead also here. And one more is, what you said, actually I'm working with other data sets, huge data sets. I'm not aware of that.
Okay, no issues. Thank you, madam. Thanks a lot.
Okay, sir. Thank you.
Next we have paper ID 143, adapting single speaker models for multi-speaker environments.
Good afternoon, everyone. I'm Yatin. So we'll be presenting our paper, Adapting Single Speaker Model to Multi-Speaker Environment. So these are the agendas of our paper, that is introduction, literature survey, existing system, methodology, result, conclusion, and lastly reference. So coming to introduction. So the text-to-speech, as the name suggests, it converts the given text into a speech output. So the existing systems of text-to-speech such as the Google Translate or Microsoft's innate technology that they have embedded in their Office application as well as their Microsoft Edge browser does not provide multiple voices that a end user can use to present their text or convert their text into a speech. Even if they offer multiple voices, those voices lack key features of a human voice such as the pitch, the accent, or the pitch, the accent, or the depth that a human voice has. But in recent years, the text-to-speech system or the domain of whole text-to-speech has taken a major leap because of the introduction of machine learning and deep learning technologies or methods. So deep learning plays a major role in text-to-speech in current day, where deep learning's one of the concept of deep learning, that is neural network, is implemented into the text-to-speech, which helps the text-to-speech produce much more natural sounding options of voice that a end user can use to convert their text into a speech output. So some of the components that we have, or the technologies that we have used in our paper is Tactron 2, WaveNet, as well as speaker encoder, which will be further explained by my friends.
Good afternoon, everyone. So continuing with the literature survey we have done, the first title we have Deep Voice to Multi-Speaker Neural Text-to-Speech. So here some of the features of this paper are, the authors here have introduced a technique to augment neural text-to-speech, wherein they have embedded to generate the different voices from the model. This is done by integrating the WaveNet spectrogram to the audio neural vocoder, and they have used it with the tachytron. So coming to the advantages, the Deep Voice 2 demonstrates significant audio quality enhancement. This means that there is a betterment in the audio quality compared to the previous models. And another advantages, as discussed, is that if I have given an input in my single voice, we can get a variance of my voice, and the voice which I get from resembling my voice is also very similar to what I intend to get. So some of the disadvantages which we are having is the tachytron model which we use here. It is very sensitive to the hyperparameters which we give, and also to the data pre-processing which will happen in the model. Another one of the main disadvantages is this model requires a minimum amount of a threshold of what we call it as the training data. For example, if I have to train the model in my voice, in this case, in this model, I have to at least give 30 minutes of my voice to the model so that it can get a high quality. It can
and loss for speaker verification. So the method here proposes a new loss function known as generalized end-to-end text. So the main advantage of using this loss function is that the training will be more efficient, but the disadvantage is the same thing as before, like the performance degrades dramatically with large scale data. And another disadvantage is that it is difficult while dealing with imbalances in training data. So the last paper is that with the title Transfer Learning from Speaker Verification to Multi-Speaker Text-to-Speech Synthesis. So the method uses a speaker encoder network trained on a speaker verification task. So the advantage of using this is the model is able to transfer the knowledge of speaker variability, and the another advantage is that it can synthesize natural speech from speakers that were not seen during the training also. So, but the disadvantage here is that the system has insufficient generalization ability, and the computational requirements of the system make it unsuited for embedded applications. So coming to the existing systems, so first thing is speech verification and text-to-speech systems have already progressed, but there are challenges which are yet to be achieved to complete the authenticity. The concerns about preserving the speaker identity underscore the need for comprehensive solutions beyond speaker authentication. So the Deep Voice 3 improves the training speed and audio quality, but there are challenges also here. Tachytron 2 enhances synthesis efficiency with the MEL spectrogram. So in summary, the progress have already been made, but there are a few ways in which we have enhanced this further. So the main proposed idea or the methodology will be explained by the other.
So good afternoon, everybody. So the main methodology that we are going to use is, so we're going to use 3 neural networks in concatenation. The first one is speaker encoder network, synthesizer, and a vocoder. Why are we using these 3 together? It is because we are not only converting text to speech, but we are also giving variations of your voice. So let's say when you're trying to train your OK Google on your mobile, the problem with that is if you don't want it to recognize your particular voice, you can just train it by the word OK Google. But when you have, let's say you're sick or your voice has changed a little bit, it will not be able to recognize. So what we are trying to concatenate with that existing model is our variations of voice, it must be able to recognize that it is me. So what we are proposing is a model architecture where the speaker encoder, a speaker encoder network, sequence to sequence synthesis network, and a vocoder. A speaker encoder network is trained on diverse data set. We are all using this in frozen settings that are already available. The main change that we are trying to implement here is in the architecture. So in all these models, they are using 3 LSTMs and 256 embedding size. What we are trying to do is we're going to increase the embedding size to 512 and then use 5 LSTMs. So that so most of the models out there, which Sumuka explained, it is going to take 30 minutes for some to and the OK Google model that is already available, Bixby Siri. The problem with that is you have to give a few words to recognize your voice. It takes around 3 or 4 minutes to just get your voice to recognize. What we are trying to implement here is a 3-second sample of your voice. The fastest that you can get now is up to 5 or 6 seconds. By using 5 LSTMs and increasing the size to 512, we are able to cut down it by 12.5%. That is around 3 or 3.5 seconds of the input audio that you are going to give. It is going to convert into it will be able to recognize, and then the features of that voice will be taken down with that 3.5 seconds audio sample. So the input 40 channel MEL spectrogram are passed to the network consisting of a stack of 5 LSTM layers of 1280 cells each, followed by a projection of 512 dimensions. The final embedding size is created by L2 normalizing the output of the top layer at the final frame. This is the model architecture that we are trying to implement. These are the 3 neural networks that we are using. In the result of all this is a multi-speaker speech synthesizer enables interface on random untranscribed audio without requiring alignment with text. Achieves zero-shot adaptations to unfamiliar speakers, capturing speaker characteristics directly from present audio, even from those absent in the training. We can use train test split to do this. Model requires only a brief audio sample, few seconds long, to capture vocal features for high-quality synthesis. Interference process is highlighted with distinctions in spectrograms, such as lower bass frequency for prominent male speakers compared to a central and bottom for female speakers. To conclude our literature survey, multi-speaker TTS with neural network and sequence-to-sequence network achieves voice samples for both familiar and unseen speakers via transfer learning. Model falls short in flaws where we are not able to gain that accent of human, which is whatever I'm talking, it is not able to gain that much of an accuracy, but it is still better than the ones out there, which is available in Siri, Google, OK Google, that is, and Bixby from Samsung. Proposed improvement involves conditioning the synthesizer on independent speaker and accent embeddings if sufficient training data is available. These are the references that we've used. Thank you.
Hello.
Hi, sir.
Yeah, Vidyadhar, I would like to know, on what data you operated and what was the size and what was your result. And there's no data about that is presented in the PPT.
So this is a literature survey that we have conducted. This is purely literature survey.
Okay.
We are trying to present that, and an improvement in that survey is what we are trying to implement, sir.
But the title doesn't speak about, you are making a literature review.
Oh, sorry.
Right.
Same question arises, what model you are going to use, what is the data set, and
Sir,
identified any, outcome of this literature survey, what will be the outcome of this?
Sir, so the outcome will be a model where when you give, let's say, a 3-second sample that
Which model is that? Have you identified any specific model for that?
Sir, this is the model that we'll be using, exact model architecture.
Now, do you think that this model is not available right now?
Sir, this is available. What we are saying is we're making an improvement to this existing model. The current model, it takes around 6 to 7 seconds of audio sample. We are trying to increase that by increasing the LSTMs in the current model and increasing the embedding size. By doing so, we are able to cut down the audio input, that is by 3 seconds. And when you're using, like I give an example, when you concatenate with this in the existing model of Google Bixby, let's say in Google model, if you say OK Google without training it, it will be able to wake up. But once you train it, you need to give variations of your voice to every model. When you do so, let's say you are sick, and if there is a variation in your voice, it will not be able to recognize exactly. What we are trying to do is not just one, but we are able to get variations of your voice by capturing just the acoustics of your voice, not the exact features, but your baseline. I had given an example here.
How will you handle the background noise?
Sir?
Background noise.
So that is what we have used, sir. We were able to get Tracotone true. And most of the encoder network, we are using it in the frozen settings. That is, which is already available. So it is mostly easy for us to get it run. Thank you.
No, my turn is not over.
Okay, sir, sorry.
Very nice. Are you a faculty or are you a student?
Student, sir.
Very nice. You are a BTech, BE student or
yes, sir.
BE student?
Yes, sir.
Oh, very nice. First of all, congratulations, and you have presented really, it was very nice.
Thank you, sir.
But you know, can you go back to that literature survey? Now, my simple question, you have put a feature, advantages, disadvantages. How you could able to extract disadvantages? Nobody will say, I am having a disadvantage in my work. And you have selected something 3 plus another slide. I noticed around 6 to 8 papers. You may had a literature survey. How you wrote the disadvantages?
So that is by comparing the existing technologies with what they have done. Let's say in the first paper, the training time was 30 minutes. But with the existing models out there, the time is lower already. So that we were able to recognize a few.
No, 1 second. You see, you cannot comment on the poor performance because you have not built the model.
Okay.
People who developed the model, if you give something input, the model has to respond. On that basis, they are going to say, our performance is say below 70% or 60% or whatever metrics. I'm not going to comment on the metrics. But you should be very careful inputting the other researcher the performance disadvantage. But what they say is, if you go through these papers, honestly I'll tell you, this is a learning for the engineering students. You have to see in the conclusion part. They are going to say, where is the scope for future enhancement? So there they are going to say, this is what my limitation is, and there is a scope to improve.
Okay.
You should not say disadvantages. If you say disadvantages, you are not built. You have made only study. If you study one paper and you can able to make a comment, I don't have any answer for this, because you have not done anything.
Okay, sir.
Those people, I think this gentleman, they have worked and they have built, but without applying anything and directly if you make a comment, I think it will be very harsh.
Yes, sir.
Now, commenting on anyone is very easy, right? But this is one aspect. Second aspect is, and since you are all young and it is very nice, but you would have taken one small problem, and at present you said whatever today context and 2000 and all, where is that gap? You could have observed the gap, you would have fulfilled that gap. That is what Srinath and Ravi Kumar clearly said. This is where my contribution is. These are the one performance has come down with our model. We have built a model, then our performance can be improved like that. You can able to say, for example, KNN method is there, right? If it is going to be solved with SVM method, support vector machine method. So this is what in machine learning or whatever you have chosen, and text to this speech. And here I am having a problem. If you see, observe carefully, whenever you, I think somebody said there is some fever or some disease is there. Why?
Yes,
you only
yes,
said,
yes,
okay. No, technically, if you observe today, the technology is totally different. I am having in my home, and let us be frank, I am having a Alexa, okay, I am fitted with that. Again, whenever I want to say, directly I say, and you know, in the remote also, it will go. Because basically, it works on a genre. And our Indian accent is different, UK accent is different, American accent is different, Australian accent is different. So what these people are going to do is, they will localize the geographical place. See, now whatever I am speaking, you can able to easily understand. But if you go to Australia, they will speak very fast. And in USA, sometimes we may not understand because dialectic will come. See, these are the inherent features of any natural language. If you see in Karnataka, I think you know Kannada, right?
Yes, sir.
In Karnataka, our Mangalore accent is different and all. What these people are going to do is, whenever you take, they will select the country. I think you enabled this Alexa and all, right?
Yes,
Which
sir.
place? Yet while configuring, it will ask. That is what now text to speech. Then moment I am going to speak, it will understand. But I am not saying everything. Okay, even there is a performance issue. Okay, so even today also. So like this, you would have studied. That's what, because I think you are in 7th semester. Okay, very nice. And this is where there is a scope.
Sure, sir.
Okay, I think you can do this, because still one more year, I think 6 more months is there. So I think you can able to do better work, and you can able to present, since you have a potential to do. In fact, I am very nice to hear all these you have done, and some my inputs I have given. I think you can consider. I hope I leave it to you.
Sure, sir.
Okay.
We're going
and
to
very nice presentation also.
Okay, sir. We're going to rename it disadvantages to limitations and then work on your input.
No, that you have to see the conclusion part.
Okay.
See, you cannot say your paper is not good, right?
Yes, sir.
Whenever if you say my paper is not good, means I think we have a problem.
Yes, sir.
Nobody will say.
Yeah,
But
sure,
future enhancement you have to see.
Oh,
See,
sure,
first
sir.
abstract, future enhancement, then the model, then the performance issue, then the metrics, data set, all these. There are so many parameters. I think if you see IEEE or ACM regularly, I think you will get an idea.
Sure, sir.
And this is what my input. I think you can able to talk to your mentor. Definitely they can able to help you. Okay.
Sure,
That's
sir.
all
Thank
my
you.
suggestion.
Thank you, sir.
Thanks a lot.
Okay, before we move on to the next presentation, I would like to introduce our session chair, Dr. R. Chidanandappa. Sir is working as professor in Electrical and Electronics Engineering Department with 19 years of experience. Sir has obtained BE in UBDT College of Engineering, Davangere, Master's degree in Electrical and Electronics Engineering from MC Hassan, and doctoral degree from VTU. Research interests are in the distribution automation, smart grid with power electronics control, power quality problems, electric vehicle integration to grid with battery storage application. Sir is also the head of Center of Excellence, Center of Energy Management and Testing of Electrical Apparatus in Electrical and Engineering Department, and actively involved in industrial consultancy and testing. Sir is also reviewer of International Journal of Electrical Systems and Components, Taylor and Francis Group, International Journal of Electric Power and Energy Systems, International Journal of Engineering Science and Conferences. He has published 25 papers in international journals and conference with SCI and Scopus indexing. Sir is also a program invigilator of VGST KFIST L1 sanction research project title Establishment of Real-Time Monitoring System R&D Facility for Efficient Operation of Campus Power Distribution Network with research fund of 20 lakhs. I welcome you, sir. Next we move on to paper ID 60, Capacity Estimation in Automotive BMS with Intelligent Techniques by Chaitra Ganesh.
Good evening, everyone. I am Chaitra Ganesh, working as an assistant professor in the Department of Electrical and Electronics in Vidyavardhaka College of Engineering. So my article is on the capacity estimation in automotive battery management system by making use of intelligent techniques. So this is the agenda of the presentation. So coming to the introduction part, as we know, with the surge in the prices of the fossil fuels and the growing concerns with respect to the environmental issues, specifically pertaining to the carbon footprints, there is a need for a greener transportation method. And electric vehicles, they prove to be a sustainable solution for this. So electric vehicle, particularly with the lithium-ion battery technology, they provide various types of advantages such as high energy density, efficiency, and longer lifespan. However, for the battery longevity, it is essential that we design an efficient battery management system, and this plays a very crucial role. So the BMS, it calculates two components. One is the state of charge as well as the state of health in order to ensure the optimal battery performance. So BMS, it eliminates overcharging, the deep discharging, and it enhances the overall performance of the battery, and it increases the longevity of it. So there are different techniques that are used in order to accurately measure this state of charge as well as state of health. And the article here, it reflects mainly on the comparison of data-driven type of method for the estimation of these capacity parameters. So coming to the literature survey, so the first paper here, it emphasizes more on the wireless BMS, wherein the estimation of the state of charge, it is done by a method of Coulomb counting. So mainly the Coulomb counting, it emphasizes on the cell balancing aspect, but however, it sort of omits the state of health parameter estimation as well as the thermal management and the safety protection aspect. So the next paper, it introduces a hybrid approach wherein the same Coulomb computing is used in conjunction with fuzzy logic. So since both of these methods are synergized together, the accuracy of it improves, and the errors that are related to the Coulomb counting method is also significantly reduced. The next paper, it provided a comparison on the extended Kalman filter and ampere-hour computing technique for measuring the state of charge again. And it highlighted while we favor the EFK's accuracy, it is also a little challenging to understand the modeling complexity as well as the prior requirements for estimating the state of charge. The next paper introduces a neural network method which is used to determine the state of health of the battery, and here the error is going to be under about 5%, and in comparison to the Kalman filter, this method is outperforming in nature. And since it also follows a non-linear approach, it considers it, this is better for calculating the battery parameters. And finally, there was one more paper that we have referred regarding the battery parameters used in conjunction with the fuzzy logic in order to estimate the state of health of a lithium-ion battery. So this again enhances the accuracy, and it addresses the non-linear aspect of the electric vehicle in batteries. So coming to the existing system, so basically in order to carry out the capacity parameter estimation, there are two types of methods that we use. So one is the model-based method, and the other is the data-driven based method. So in the model-based method, we basically go for the internal battery reactions, and we formulate with respect to the physics aspect of it. And it is very versatile and accurate also. But however, this poses a challenge in terms of complexity and accuracy. There is always a trade-off between the two. So if we need more accurate estimation with respect to state of charge or state of health, then the modeling complexity involved is also going to be quite challenging. And therefore, this might not be suitable for all the users unless you have a prior knowledge about it. But data-driven based methods, on the other hand, they make use of machine learning techniques. So it mainly reveals what are the concealed relationships in the actual battery data along with the real world. So here we do not have any modeling complexity. However, there is a computational complexity present. But since the computational part is taken care of by the machine learning aspect, this will be easier for a user to design. So here in the methodology part, we will be mainly seeing the data-driven method that is used for the capacity estimation. So first and foremost, coming to how we have collected the battery data. So we have taken the data from NASA's lithium-ion battery charge and discharge experimental data set. So here we have made use of three battery datas, battery 5, 6 as well as 7. So the graph, it highlights what is the actual capacity degradation curve of it. So here basically we are considering a battery with a capacity of 2 ampere hour, and it is only going to be viable for use up unless the charge is about 70% of the rated capacity, that is 1.4 ampere hour. So if at all the capacity is degrading below 1.4, then this is not going to be viable for use. So the same has been indicated in the graph here. And the figure adjacent to it is regarding the voltage, current, as well as the temperature waveforms when you consider a fresh battery cell as well as an aged battery cell. So the blue one highlights the fresh cell with the first cycle, and the aged cell is with respect to 168 cycle. So this is the data we have taken from the NASA's lithium-ion battery charge-discharge database. So coming to the methodology here, so we are carrying out a comparison between the artificial neural network method and also the fuzzy logic method. So the comparison between these two methods is going to be seen here. So firstly, coming to the artificial neural network method, so we have chosen the simplest form of neural network, that is the feed-forward neural network, because the flow of information is going to be unidirectional, and that is what we require in the battery parameter estimation. So we are going to carry out a training process by making use of an algorithm called as Levenberg-Markudak algorithm. So this is basically used in order to train the data which have non-linear least square problems. So here, this is the procedure that we carry out. So the data is divided into 3 sections. The training part, for the most of it, the training will be done, and then the validation, and then the testing of the subsets is going to occur. So during the training process, the data that is acquired by the model, it is continuously going to be trained with respect to the LMA algorithm. And if at all there is any error that is persistent, say up until the 6th iteration, that is when the validation check is going to halt. And after the validation check, there will be the testing of the subset. So wherein the estimated data of SOC and SOH, it is going to be compared with the actual data of the battery. So this particular testing is what we carry out for about 300 epochs here. So there is a graph which highlights what gradient we have selected at epoch 33, what is the learning rate we have applied, and the last graph, it also highlights on if at all the error is persistent up until the 6th iteration, how the behavior of the graph is going to exist. So this is the data we have got with respect to the artificial neural network toolbox that we use in MATLAB. So after carrying out this analysis for the entire epoch cycle, next what we do is we make a plot of regression. So in the regression, we are going to find the best fit for the actual capacity of the battery. So this inclination in all of the graphs here, it is going to indicate the actual capacity of the battery. And with respect to the training that we have provided to our neural network, feed-forward neural network, it is going to check which is going to be closest to the actual capacity here. And as it can be seen, the 4th graph that we have with the regression value 0.9925, so that is the closest of all. And it is therefore matching with our target variable, which is the battery capacity. So on the similar grounds, we can also carry out the estimation of battery capacity by making use of fuzzy logic approach. So in the fuzzy logic approach, again, we define the input variables, which could be voltage, current, and temperature. And the output variable, of course, is going to be the battery capacity. So we define this input and output variables in the form of the membership function. So here we have made use of the triangular membership function. And then we define a fuzzy inference system. We have made use of a Mamdani fuzzy inference system. And here, in the inference system, we specify the rules with respect to the fuzzy logic controller part. That is, what is going to be the SOC and SOH, that parameters is going to be defined. And accordingly, we are going to check our target output as a part of membership function itself as to how it is going to operate. So when it comes to the results, when the regression plot is further analyzed, we are going to get a capacity estimation graph. On the left side, this is the graph that we have when you estimate the capacity making use of a feed-forward neural network. So as you can see, the blue line, it indicates the actual capacity of the battery under test. So we have taken battery number 6 to be the actual data. And then we are going to compare with respect to our trained data, how close this is to the actual capacity. And this is the graph that we can see for it. And when it comes to the second graph, it also shows the estimated capacity, but by making use of a fuzzy logic approach. And here it can be noticed that the accuracy of artificial neural network method is much higher than the fuzzy logic method. This is the graph which validates the same. And from the same data, it can be evidently seen that the ANN approach is very consistent, and it outperforms the fuzzy logic in terms of accuracy when it comes to estimating the battery capacity estimation. The table also verifies the same with respect to different cycles of the battery, the actual capacity reading, and the neural network capacity reading for 10 hidden networks and 40 hidden networks is shown. And the third column, it also gives an information on what is the battery capacity if at all the estimation is done through fuzzy logic. And the same sort of comparison can also be done with respect to the mean square error method. So looking at the data, it can be concluded that if we are going to make use of neural network method in order to carry out the estimation of battery capacity in terms of state of charge or state of health, the results are going to be more accurate. So this is the conclusion that we can draw. And if at all we need some more accuracy, we can also employ methods such as deep learning or SVM as well. These are the results we have obtained for the battery capacity estimation. And these are the references that we have used. Yes, thank you.
Chaitra, good presentation. Your understanding about the topic is also good, and I just wanted to know, could you able to tweak the parameters, the value, the weights in the neural network?
Okay. So here, this is the neural network training that we have given. So this portion, it defines the gradient, meaning with respect to our error, what are the changes in the weights that we are making. So the gradient value is 0.0015897, and this is the reading we have at 33rd epoch. And the learning rate also, initially it is high. So this mu, it indicates the learning rate here. So initially it is high, and later on, once the data is trained enough, then this is the corresponding output we get.
Good.
Presentation is good.
Thank you, sir.
What is the deviation of the estimation of the battery from the actual battery from all the three methods?
Sir, actually here we have used...
Last one.
Yeah, the last one, sir. Yeah. So here, if we notice...
you have a number, right? Next.
Yeah, the last slide, sir.
Okay.
Yes, sir.
So the actual is there.
Yes, sir.
And other three proposed methods.
Yes, sir. So this FNN10 and FNN40 is also neural network based estimation only. But here, the hidden layer that we have used is 10 for FNN10. And for FNN40, we have used 40 number of hidden layers.
Okay.
So in accordance with that, if at all we increase the hidden layers, this is the accuracy that we are getting with respect to the actual capacity.
Actual capacity you have taken from the database,
yes,
right?
sir. We have taken it from the database.
That is the actual battery results.
Yes, sir.
But your proposed methods gives the more accurate, more than the actual value, right? Do you have any comment on that? 1.5 is the estimated actual battery.
Yes, sir.
But your proposed model gives the 1.86.
Yes, sir.
That is not actual battery.
Yes, sir.
Wherein you are trying.
But we've got the estimated value
itself. How do you
itself
validate this?
Sir, sometimes what happens is, since we are carrying out prediction, we cannot say that it is going to be exactly equal to the actual data. Maybe here what we have recorded is just the optimistic estimation that we have got. We could have got it as a pessimistic value also. But with the conduction that we have done, the result, it is showing an optimistic estimation. Does not mean it's correct than the actual data.
So in order to avoid this confusion, nowadays hardware in-loop simulation method is there.
Okay,
means you are connecting the simulation results to the actual battery, wherein you train the network and get the results of the actual battery. Both are there nowadays, integrated one.
Okay.
And all these, I mean, any other, from other literature survey, any improvement of your results compared to the other methods of from the literature survey? You are not compared with the existing models.
Yes, sir. Sir, here actually when it comes to data driven, there are a lot of techniques that we could have applied with respect to machine learning. But here, just to start off, I had started it with feed forward and fuzzy logic.
All are existing methods only, or
yes,
any
sir.
other new methods are there here?
So deep learning can be used.
No,
SVM
here,
is
here,
also.
in your work.
No, sir. We have compared only with respect
All
to these two.
existing only.
Yes,
right?
sir. Existing itself.
Okay.
Okay, sir. Thank you. Sir, the data we have taken it from the NASA's database, sir. So with respect to that, whatever the actual capacity was there, so this is the capacity degradation that we curves that we had got from the database. So pertaining to this, we have applied a similar sort of data itself, and then we have carried out. We have considered 3 batteries here, sir. So from the database itself, we have 3 samples, battery 5, 6 and 7. So for that, we have considered the comparison. Yes, sir.
No, you have only 3 batteries.
Yes, sir. Yes, sir. I will try out with a more greater sample size, sir. Yes, sir, we should have. Yeah.
The other thing is, you are telling that it's for an environmental issue you are considering. See, even the problems with the electric vehicles, what we are facing is that the electricity that is being generated, it is coming from this coal and these things. We don't know the source of energy, whether it is wind or some other thing, we don't know. So the main focus should have been where we are extracting the batteries are coming. The other problem is the cells, after the battery is used, where we are going to throw. That is another problem. So what I have heard is that it is going to be more a problem from these things than actually thinking about the environment. Environment is getting more degraded because of these things. We have to consider on like tides or something like that. The energy, alternative source of energy, that is more important.
Yes, sir.
And the spike sometimes is high and low. Almost all the times batteries will degrade by this.
No, do you have any contribution towards the finding the carbon footprints?
Sir?
To avoid the carbon footprints. Now your objective is to identify the carbon footprints, is it?
No, sir.
Capacity, but
Only the
in that way, is it possible to identify how much the environmental condition will get affected because of this?
Yes, sir. That also can be taken as a prediction, but we have not done it.
Not looked into
We
it.
have not included it. Yeah. Thank you.
Before we move on to the final paper of the day, I would like to introduce our next session chair, Dr. Anand Hulgaballi. He's currently working as assistant professor and officer in charge of Geotechnical Engineering Division at the Department of Civil Engineering, NI Mysore. Additionally, he serves as honorary secretary for the Mysore chapter of Indian Geotechnical Society. His academic journey began with a BE degree from KLES College of Engineering, Belgaum, followed by MTech and PhD from NIT Surat, where he was mentored by Dr. C.H. Solanki. His PhD research focused on seismic response analysis of reinforced earth retaining structures. His areas of expertise and research interests revolve around reinforced earth structures, geosynthetics, computational geomechanics, CFD applications in environmental geotechnics, ground improvement techniques, and deep foundations. Notably, he has authored 3 books on geotechnical engineering and published a significant number of research papers, including book chapters, peer-reviewed journals, conference proceedings amount to 50 publications. Moreover, he holds 4 Indian patents for innovative civil lab equipment designs. As an academic mentor, presently he is guiding 4 PhD students and 1 MTech students. He has supervised numerous students, guiding 28 MTech students. His professional involvement extends beyond academia, as he actively engages in geotechnical engineering consultancy work for various state and central government infrastructure projects. Some of the notable entities he has provided consultancy services include CBI, RBI, NHAI, AAI, Indian Railways, CPWD, MUDA, MMC, Infrastructure Development Department, Minor Irrigation Department, PWD, RDPR, Revenue Department, KSRDC, and Water Resources Development, among others. Total value of his completed consultancy projects amount to 70 lakhs. Prior to joining NIE, he gained international experience working at Ambo University, Ethiopia, Africa, as a part of UNDP program. During this period, he also served as visiting faculty member at prestigious Ethiopian universities such as Jimma University, Arbaminch University, Havasa University. Before that, he acquired research experience at IIT Madras under the guidance of his mentor, Dr. G.R. Dodegaudar, during his PhD and MTech studies. He has been an inspirational figure, delivering numerous technical and motivational talks at various engineering colleges in India and abroad. His contributions to academia are further reflected in his role as reviewer and editorial board member for 5 peer-reviewed Scopus Index journals. Lastly, he holds membership in several esteemed professional organizations, including the International Society for Soil Mechanics and Geotechnical Engineering, American Society for Civil Engineers, Indian Geotechnical Society, International Society for Geosynthetics, ISTE, IEI, and ACCE India. We are very honored to have you with us today, sir. Yeah, thank you. Next, I call upon paper ID 104, identification of structural damage in single-base steel frame using ANFIS software.
Good afternoon, everyone. My name is Amrita Varshini V. I am an assistant professor in the Department of Civil Engineering with Vidyavardhaka College of Engineering, Mysuru. Today's my research topic is identification of structural damage in single-base steel frame structure using ANFIS software. And my presentation contents are as follows. Now, each one of us are working or living in a place or a building which is subjected to damage, and without knowing the amount of damage that is present in that particular building, we simply trust the civil engineer and we live everyday life, right? So, as a responsible civil engineer, it is our duty to monitor each and every structure in order to prevent the damage and monitor and prevent the amount of money that is being wasted in order to maintain or retrofit or reconstruct the entire damaged work. So my current research paper, which has been done by my students, BE students, mainly focuses on health monitoring of the structures, which is a booming field in our particular civil engineering stream. As I said, every structure is undergoing deterioration and damage throughout its service life, and they have to be monitored on a daily basis. And there are many methods that are already available. One is simple visual inspection, where we can see the clear damage in each and every structural member. But this is only applicable when we can visually see that particular structure. It cannot be applicable in the places where the complex structures are there, where the structure is hidden inside. So the next method is local non-destructive methods. We have various NDT tests that are there, but again the restriction is we should be able to reach that particular point in order to find the location. And second disadvantage is we cannot identify the particular location where the damage is present. So the third damage identification method that we are mostly using is model-based approaches, and for my study also I have considered one of those model-based approaches. In order to train and get my data, I'm using ANFIS, which is a hybrid of both EAN and FIS, which is available in MATLAB software. This particular, as we all know, it uses neural networks as well. It is a combination of both neural network and fuzzy rules. So we get it maps the new inputs and outputs with respect to the membership functions, and FIS is basically used to measure the input and output variables. Now coming to the literature review, I have asked my students to go through numerous papers. They all came up with ANN method and FIS method. That's why I thought of, is there any method which combines both the advantages of these two, where I got to know that the rules generated by FIS tool helped me to connect improve my accuracy in ANN, which that is the reason why I chose ANFIS software. The gap that I identified in that particular works is that there are many methods, yet there is very less work that is done in ANFIS software, basically to identify the location of the damage. Now coming to my objectives, my main objective was to detect the single and multiple damages that are caused in a single bay steel frame structure, and my methodology consisted of, I generated the model where firstly I had created experimentally, I had created one steel single bay frame structure, and I got some data through that, and I validated the same results in the Abacus software, which works as which uses finite element method, FEM based software, that helped me generate more damage cases, as it was not possible to do manually in the real world. So I used the Abacus software to obtain more damaged cases through that by validating what I obtained through the experimental results. Then created as many damaged cases as I required and collected all the data that are required to train the ANFIS model. Then I trained 70% of the data in the ANFIS, and the remaining 30% of the data I kept it for testing. Finally, I performed the evaluation for different membership functions that were available in the ANFIS software, and concluded with the results. Now coming to the methodology, this was the single bay frame that I had considered. The reason why I have kept it to the very small dimension is I had to create the same model manually, physically, to test in my to test with the accelerometer equipments. We conducted this experiment in Siddhganga Institute of Technology, where these are my details of the steel frame that we had considered. It had a Poisson ratio of 0.2, density of 7.67 into 10 power 3 kg per meter cube. Now coming to this, we can see these are the two different damage scenarios that I created in this particular frame manually, physically. The frame has been divided into 6 different elements, and the Young's modulus of different elements were reduced, which in turn reduces the stiffness of the material. The stiffness of the material reduction can be easily seen with the natural frequency. So using the accelerometer equipment, we can easily find the natural frequency. That is what we did. And whenever there is a damage, there will be a loss of mass. This directly indicates a loss in stiffness, which can be found out using the natural frequencies. So first we identified the natural frequencies for 3 different modes for undamaged case, and second scenario, scenario 1 and scenario 2 were the first 2 damaged cases, where we reduced the Young's modulus for different elements. Once we are done with this, then we created an Abacus model with the same properties, and we compared whatever the damage that we obtained manually with whatever we extracted through the Abacus software. So for all the first three modes, we obtained almost an accuracy of 95+%, which made us validate that whatever the model that we have created in Abacus software was same as what we had manually, experimentally done. The reason why we did this was we wanted to get more damaged case scenarios. So using the Abacus software, we created as many damaged cases as possible, and we obtained many data sets by reducing the Young's modulus of that particular element. Next, we developed the ANFIS model, where we trained, as I said, 70% of the data set that we obtained. We had 7 different inputs. That first 6 input were the Young's modulus of each element, and the last input was the mode shape, whereas our output data was natural frequency, and the iterations that we had was 1000, because we started with 100 iterations, and as we increased the number of iterations, we identified that the accuracy was increasing, but after 1000 it almost went constant and it was taking a lot of time. So we kept it as an optimum iteration as 1000, and we tried for all the different membership functions which are present in the ANFIS software. Later we compared the natural frequencies that we obtained for each individual membership function with the natural frequencies that we obtained in the Abacus software. Now we got the percentage of variation, and this was helpful in conducting the performance evaluation. We had several correlation coefficient method, regression method, numerous errors, and as well as efficiency methods. We can see clearly that the Gaussian membership function gave almost 0.99 accuracy, and we can see the minimum errors when compared to the other membership functions, and the regression value was also very high, 0.99. Although all the membership functions gave us a very good accuracy, but we could rely more on Gaussian membership function. So this was the graph scatter plot diagram. And coming to the results, as I said, the Gaussian membership function had gave us an outstanding result of locating the damage. What we could do now is, if we just monitor on a regular basis, if we get the natural frequencies at equal intervals of time, we can easily identify where exactly the damage has been occurred. So with this particular software Gaussian membership function, we could relay it up to 99%. So this was our result and conclusion. Thank you.
Yeah, it was a very nice presentation. First of all, I want to know, this study was carried out by you or your students?
Sir, actually the experimental work using the accelerometer, I did it during my MTech period in SIT, which was published earlier.
Okay.
Now what we did was we got that particular data, we created as many data sets as possible, and then we used ANFIS software and did this, and this was done by my students, BE students.
BE students, yeah. Very nice work actually.
Thank you,
I have a few queries,
Sure,
so if I get the clarification, I'll be very happy.
Sure, sure.
Can you just go back to that, the Young's modulus values you have changed?
Yes.
The input
this one,
parameters.
this one, yeah.
Not this one. Just
Scenario.
Yeah, this one.
Yeah.
Now the scenario is like you said that you are going to reduce the Young's modulus, right?
Yes.
And in fact, when we consider any structure, your stiffness, axial stiffness is one thing, which is EI, and we do have the other stiffness, EA value. Yes. So what about that effect? That's my first question. Then coming to the other properties like Poisson's ratio, yes. Then you do have this moment of inertia, then also yes. The material properties.
Yes.
It's a steel frame, right?
Yes, sir. Yes, sir. It's
steel frame.
Yes.
Now, coming to the other properties, talking about other properties, how those properties are going to affect these results? Okay, because this entire work, concentrates on only Young's modulus. Now what about the other parameters?
Yes, sir. So the main concept that we used here was we had to create damage manually or physically. So whenever we do create a damage in one particular element, what we actually do is reduce the mass of that particular element. So when we reduce the mass of the element, now the damage can occur due to various properties, as you mentioned. But this particular work mainly we do not know with what particular property that damage has been occurred. But whenever the damage occurs, there will be a loss of mass. So
Sorry.
Yes.
But instead of considering only Young's modulus,
yes,
I would suggest your axial stiffness and the flexural stiffness, EI
yes.
and EA.
Yes, sir.
Because any member you consider,
yes,
it depends on the cross section.
Yes,
so the
sir.
damage and the weight, whatever you are talking about.
Yes.
So that could have been more meaningful, because this becomes a completely, an individual parameter.
Okay, sir.
EI and EA could have been more, productive, I can say. And the other important aspect is
Yes, sir.
like, how do you, implement this in the field?
Okay.
Because fine, you are predicting the damages and all those things are fine, but
Yes.
nowadays we do have that image processing
Yes, sir.
things and
Yes,
all those
yes.
things are there. So can you just elaborate on that?
Yes, sir. Sir, what we can do with what is the actual conclusion is, whenever a new structure is built, that we usually treat it as an undamaged structure. And once we extract the natural frequencies of that particular structure, we will have what is the base natural frequencies that is there. Now, once there is a damage which results in stiffness, and stiffness is related to natural frequencies. That is the main motto of our particular project work. So what we can do is we can use NDT tests like resonance acoustic testing methods, where we can obtain the natural frequencies at regular intervals. So once we identify there is a change in natural frequencies, that definitely says that the structure has undergone damage. And only thing, the identification of the location, that can be done using this particular thing. If we just train the data with whatever the data we have, and if we after regular monitoring, if we keep on testing the data for that particular natural frequency, we can obtain where exactly that particular problem, where exactly that damage is occurring.
Yeah,
that can be identified.
In some cases, for example,
Yes,
forget
sir.
about Mysore. Mysore is in zone 2, so we are not
Yes.
worried.
Yes, sir.
But what about the places like, just like, you have the Gujarat or Northeast region
Yes.
where we have zone 5,
Yes, sir.
where, you are going to expect a lot of earthquakes.
True.
So there, this natural frequency, what you are going to consider, so that's going to be affected. Right? So
Right.
let's say today you are doing the test and you get some natural frequency, and suddenly, there will be an earthquake. So
yes, sir. Seismic.
yeah,
Yes, sir.
then
This study is purely only applicable for natural frequencies. Induced frequencies we have not considered yet.
okay, so that is not considered.
Yes.
Anyways, it's a very nice work. I really appreciate,
Thanks.
and I really thank you for coming to NI and
Thanks.
participating in AI Summit. Thank you so much.
Thank you, sir. Thank you.
Other part of the building, in any part of the building, if there is damage, you will be able to analyze, is it, tell which part of the building is getting damaged.
Yes, sir. That is the motto of this particular work. For that, we considered a simple one single bay. This can be applied for multiple bays and eventually a whole building.
No, how can you pinpoint a particular area which is getting degraded?
Yes, sir. Through the natural frequencies. So whenever there is a loss in mass,
Yeah.
that definitely indicates there is a loss in stiffness. And stiffness is a measurement that is directly proportional to the, that is related to the natural frequencies. So once we get that natural frequencies data, when we import here, obviously we have trained using the damage scenarios. So because of that particular case, we can identify where exactly, that itself will give us where exactly the damage has been occurred. So if
Sometimes you create manual damage and see, is it?
yeah, that is what we done, sir.
Yeah.
We created
But,
damages.
manually getting damaged and by time getting damaged
Yeah.
are two different aspects of the same thing. I
Right,
suppose.
sir. So usually this method is also applicable in huge bridges that are being constructed. And usually the damage which occurs in bridges are deep within, and surface damages can be easily seen through visual inspection. So this particular method holds good where we cannot see where the damage occurs. So when the damage is within or the interior of that particular structural member, say a beam, say a slab, so in that particular member we can identify where exactly that, although we cannot pinpoint accurately that this meter we can find, we have some area in within which the damage might be there.
Okay, in that
So
case,
which helps us in reducing the problem for us.
the other thing is that you are telling that loss of mass is an indication of the damage that is being done. Right?
Yes, sir.
Sometimes the structure might be loosened, but might not have lost its mass. In those cases, how are you going to do?
Sir, usually whenever majority of the damage will causes loss of mass, loosening of structures may only be seen in joints where in case of steel, in joints where they have welded or they have used bolted connections. So usually the bolted connections or the joints are done where we can visually see. So the interior damages occurs, whatever the damage occurs, no, that relates in loss of damage. So let us say termite attack. So what happens, we cannot see whether this is completely safe, but inside it might be a complete hollow. We have seen many cases where while constructing the houses, they will use wooden chunks in next to the building blocks, and they construct and they finish off with the plastering work. But after a long time, what happens? The termites will attack. So again, there is a void that has been created there. So yes, sir. Okay. When
see this, there is the mass is here.
Yes, sir.
Inside the part, it might have got loosened. Correct. If there is loosened, the mass is there only.
Yes, sir. Yes, sir. Yes.
Okay. Nothing is there. There is no loss of mass.
Yes, sir.
So you're always trying to say that mass is the one which is determining the strength of that material.
So even mass is reduced due to corrosion and various factors. Coming to what you're saying is mass is not reduced, but there might be loose connections. So usually the connections are done in case of steel structures, connections are done at the joints which are visible, sir. So we do not need a particular NDT test to check whether this type of method to check whether there is a damage, because all these bolted connections or welded connection, there we will have the loosening of the structure. Any steel structure will be jointed at the joints only, sir. Maybe a beam to column joint or beam to roof joint. So this joint is easily visible to us, and we can check whether the connections are loose or not.
Okay, you are concentrating on joints, right? Mainly.
Why he is getting confused, because in your entire study, nowhere you have mentioned about the mass. The weight.
Okay.
But when you were saying, you said the mass.
So Young's modulus is related to mass.
No. It's not related to the mass.
Stress. Okay. Stress by strain. Sir, the reason is whenever, I did not mention, as you rightly said, I did not mention anything related to the mass, but that is the main motto why we considered reducing the Young's modulus.
can I just, I don't know.
Yes.
Can we use sound waves to predict the
Yes, sir.
brittleness?
There are ultrasonic wave testing machine is there. That is a simple, as I mentioned, it is a local non-destructive method. If, for example, if we get a consultancy work where we want to check whether this particular beam is having the required strength or not, we can use that particular machine and we can check its strength. But only thing is we should check for entire beam. See, that might not be possible on a day-to-day basis. So if we obtain the natural frequency for the entire structure at once, once in a month or twice a month, we can identify where exactly the damage is. But in using that particular local non-destructive testings like ultrasonic pulse velocity, we have to first identify where exactly the damage is, and then we have to check what is the percentage of damage that particular thing has.
Then we can use that broader one, first one.
Hmm.
There is problem. Then go to particular thing where exactly the problem is.
Yes, sir. Yes, sir. That is being used generally, sir. Local, it's a local non. We, as sir also mentioned, we have different X-ray scanners also that are already available, but we have restricted to the AI method. So.
Amritarsini, very good presentation, and you answered all the questions. We appreciate that.
Thank you, sir.
Thank you.
Thank you.
With this, we have come to the end of today's session. I now request our session chairs to issue the certificates to participants in the same order in which the paper was presented. To begin with paper ID 49, extensive analysis of deep CNN based multispectral palm print verification system on all fusion levels. I request Dr. Srinath S. to kindly present the certificates to participants. Next, I would like to request Dr. Ravi Kumar sir to kindly present the certificates to authors of paper ID 143, adapting single speaker models for multi-speaker environments. Now I request Dr. Chidananda R. sir to present the certificates to paper ID 60, authors of paper ID 60, capacity estimation in automotive battery management systems with intelligent techniques. And at the end, I request Dr. Anand sir to present the authors with the paper ID 104, structural damage detection in steel frame using ANFIS software. With this, we have come to the end of day one of the International Conference AI Summit 2023. I thank all the session chairs for accepting our invitation and agreeing to be part of this event. Thank you all. I extend my thanks to all the student volunteers, participants, teaching and non-teaching staff of all the departments, heads of the different sections for spending your valuable time on this day. this, as we all know, second day's session will all be in the online mode. All the remaining papers will be dealt in the online mode. Thank you all.